Hi everyone, welcome to Vedantu JEE English. I'm Diksha Kaushal, your chemistry master teacher. And everyone, let me know in the comment section if I am visible to you and audible to all of you or not. And it's literally freezing cold here, freezing, right? I'm not even able to pick pen and write something over here. But yes, after some time, I'll be able to do that, right? So, cation rearrangement. Okay, I think you guys are discussing your exams or what? Is it? Very, very good evening. Very, very good evening. Yash, Rock, Visible. Okay, perfect. So, firstly, so sorry for being late. Actually, if you all know that uh, I am from Punjab, and in Punjab there is Diljit Dosanjh concert right in Ludhiana. So that's why I was stuck in traffic. Yeah, there was like literally traffic jam over here. So yesterday also Punjab was totally like closed, right? So that's why I was not able to reach today also. Concert is happening. So that's why full on jam everywhere. I could see the traffic jam. Horrible it was. Right? So that's why I just reached home. Okay. Yes. A word for me. You can teach me Telugu. I'll learn it for you, and then I can also I think the reason I'll tell you one reason that why I don't speak like uh, Telugu language or any other language, Malayalam. The reason is because I'm a little bit scared, right? So I feel that when you genuinely respect some tradition or some other state, right? So when you actually want to speak their language, you should know the accent as well, right? So I'm very scared of that thing. What if I just utter some word and I'm not able to pronounce it well? So I think that's kind of disrespecting it. So that's why I very, very rarely you will see me speaking it. But yes, when Gopika ma'am, Baswa sir, or Shreya sir, right, they teach me some of the words, right? Then I surely learn it with the proper accent. So I know some of the words like Adipoli, right? So Adipoli class, this is going to be. And yes, so let us start the class. Ma'am, Chandi. Chandi, it's Chandi. Ma'am, duration is going to be around 2 to 3 hours, okay? 2 to 3 hours. Okay? Chalo. Andraki Namaskaram. Andraki Namaskaram. Yes. So, Andraki Namaskaram, that I know, right? And Namaskara, Vanakkam to everyone here. So, shall we start it from scratch, ma'am? Yes, from scratch we are going to do it. Shall we start if you are all ready to start physical chemistry then with me, right? So, today is 31st of December, right? Last day of 2024, and after like tomorrow we are going to wake up in 2025, right? So maybe next year you will wake up right in your dream college, right? If you actually prepare well in this 21 days that you are left with, right? So everyone, let us start the session, last session with Diksha ma'am for 2024. Okay, chalo. So guys, already I have like handwritten notes for you. So I'm going to firstly sum up everything, right? What we have done in mole concept, right? After, Aja, tell me one thing. Do you want to do mole concept firstly or structure of atom firstly? Right? I'll see the majority here. Who all want to do mole concept? They can write M. Who wants to do mole concept firstly? They can write M. And who wants to do structure of atom firstly? They can write S. Right? So according to that, I'll teach you either structure of atom or mole concept in today's class only. But I just want to know what you want to, because mole concept is a short chapter. It's not a very lengthy chapter and the theory is very less. But in structure of atom, the theory is like large and it also includes formulas, right? Theory is also big. I won't say the theory is short there, right? So I can see So let's start with the mole concept only. Okay. So very, very shortly, I'm going to tell you, summarize everything here, right? So all the focus on the screen right now for next 30 minutes or maybe 20 minutes, the full focus should be on the screen. Okay, full focus should be on the screen. Right. So if you talk about matter, right, matter, we know that it is basically solid, liquid or gas, that is called matter. Matter is anything that is made up of indivisible particles like atoms, that is called matter. Right. So matter can be divided into two parts, physical and chemical. Right, on the basis of physical properties, like how closely they are sitting together, on the basis of that, we divide it into solid, liquid and gases. Right, solids are basically which are very closely packed, liquid are loosely packed as compared to solids, gases are like very loosely packed, right? Okay, so here basically what happens here in solid, the force of attraction, Fa means force of attraction. Force of attraction is stronger as compared to thermal energy. T means thermal energy. Now, when you talk about a solid, we know that the force of attractions are greater. Thermal energy means with heat, right? Will they be able to, how much energy you will require, right? So thermal energy is not that much here, right? But force of attractions are very high. Right, if you talk about liquid, here force of attractions are okay in comparison to thermal energy. But if you talk about in gases, force of attractions are very less, right? They are not like linked to each other, right? They are very loosely packed. That is why we say that solids are incompressible, liquids are compressible, gases are also compressible. So these are the little things that you must have done in earlier classes. Then we talked about the chemical composition on the basis of chemical thing, right? On the basis of chemical, like what is the composition, how these matter are divided into different parts, right? So on the basis of chemical properties, they are divided into two parts. First is pure and then we have mixture. If you talk about pure, pure means something that is definite. Like for example, I say elements and compounds. Now, if I talk about, let's say I'm talking about a gold chain, right? I'm saying it is a pure gold chain. Like there is not even anything that is included there. That means I am not talking about any alloy. I am saying proper pure gold chain, right? So it chain though will not be able to make it from that, right? Because pure gold is like very soft, right? It's very soft. Right? So that's why pure gold chain, if I talk about, that is a pure element, right? In that elementary state, you will have all the gold atoms which will form a metal, right? If you talk about a compound, if I talk about that I have a glass of water, it does not have any impurity. So that means all the molecules are of water. So that is the pure state. We have elements and compounds. But if we talk about mixture, in mixtures we have two kinds. I am saying in water you have added sugar, that is a mixture. You have added salt, that is a mixture, right? So in mixture you have homogeneous and heterogeneous mixture. Homogeneous mixture means if you have added sugar in water, right? We know that at every sip you will have the same content of sugar and water. But if you talk about if you have added soil into the water, we know that in the bottom the soil will settle down. So that means we know that on the upper side very less soil will be soluble in that, but in the bottom, right, you will see that it is somewhere in the bottom a lot of soil you will see. That means it is not a uniform composition, right? So that was about the matter. Now next is matter is actually tiny particles. So if you talk about tiny particles, matter is made up of tiny small particles. These small particles are atoms or molecules. If you talk about atoms, atoms are what? Atoms are like hydrogen atom, carbon atoms. These are the atoms. If you talk about molecules, now molecules can be homoatomic or heteroatomic. If you talk about homoatomic molecule, that means it consists of only one element, right, that is combining together, like H2, O2, N2. But if we talk about heteroatomic molecule, in this two different atoms are combining together to form a molecule, right? So for example, H2O, NaCl, HNO3. So here you have hydrogen, nitrogen, 3 oxygen. So different atoms are combining together to form a compound, right? So that is the difference between a compound, an atom, right, a molecule, all these things. Now let us talk about the atomicity. From here the question can be asked. So what is atomicity? Atomicity is the number of atoms in the molecule. So if we talk about here, this is C6H12O6. If we talk about this particular slide, in this you have atomicity. how many atoms you totally have. You have 12 plus 6 plus 6. That means we can say we have 24 atomicity, because they have not specified which atom they are talking about. If they specify that atomicity of carbon in this molecule, then we can say we have 6 carbons. Atomicity of hydrogen in this molecule, we can say 12 hydrogen. Atomicity of oxygen in this molecule, we can say 6 oxygens you have in this molecule. So atomicity will be 2. Right? So for example, someone is saying it is diatomic molecule. If I talk about H2, right? H2, O2, Cl2, all these are diatomic. That means 2 atoms are combined together to form a molecule, right? Okay, so if I talk about O3, it is a triatomic molecule because its atomicity is 3. Okay, so that is the concept of atomicity. Okay, now if you talk about very important thing here, that is molecule is equals to atomicity into atom. So if you talk about H2 molecule, that is nothing but 2 is atomicity and that atom is hydrogen. If you talk about O3, 3 is atomicity and oxygen is the atom. If you talk about N2, 2 is atomicity and N is the atom. Okay, so these are the small things here. Next is the representation of mass number, atomic number, right, and that element. So what is the representation from here? Very simple question can be asked, very simple, right? And also this is very useful in understanding full chemistry, right? Okay. Now, what is this A? What is this A and what is this Z? This A is actually the mass number. This A is actually the mass number. This Z is the atomic number, guys. This Z is the atomic number, right? If you talk about the mass number here, right? The mass number I am talking about. Mass number means the number of neutrons plus protons. So always remember, right? When we talk about a nucleus, we'll also study the structure of atom, right? So whenever we talk about a nucleus, in the nucleus, right, you have protons and neutrons, right? Okay. Yes, you have, beta, we will go from basic to advanced only. Okay, just give me some time, right? So we have neutrons plus protons, right? So here you can write neutrons plus protons. And what is atomic number? That only consists of protons. So they can ask you electrons from here, right? This and that they can ask you, right? Okay, so X is the element, A is the mass number, that means number of protons plus neutrons, Z is the atomic number. Right? Now remember, for a neutral atom, if you talk about a neutral atom, number of protons and electrons are going to be same. But if you talk about any ion, they are not going to be same. If you talk about an ion, it is going to gain the electron. If you talk about a cation, it is going to lose the electron. Right? Okay, chal. Now let us see this table, right? This though you should always remember this chart, right? Okay. So basically what you need to remember, electron, proton and neutrons, you need to remember its charge, its relative charge, its absolute mass and its relative mass, right? Firstly, let us talk about the electrons. So electrons is minus 1.6 to 10 raised to power minus 19. Proton is also having the same charge but with the positive. That is why if you talk about the relative charge, it will be minus 1 and plus 1. Neutrons don't have any charge, it is completely 0. Okay, if you talk about the absolute mass of electron, that is very useful. You must know this, right? Okay, that is 9.1 10 raised to power minus 31 kilograms, 1.6 to 10 raised to power minus 27 kilograms, and protons and neutrons have the same mass. Okay, it's not exactly same, right? It's not exactly same, but in chemistry we take it as approximately same only, right? For our calculation we take it as approximately same only. Right? Okay. Now, the next question that arises is, what is, ma'am, AMU? Right? What is AMU? Atomic mass unit. Right? So, let's talk about atomic mass unit. What was the need of this atomic mass unit? But before that, let me just teach you this thing here. Okay. Now, I am saying that basically, if you talk about, as I told you, that mass of proton and neutron are quite similar. They are not exactly same, right? If they ask you that exactly which mass is greater, then mass of neutron is slightly greater, approximately equal to proton. And if you talk about mass of electron, it is very small, right? You can see that it's minus 19, sorry, it's minus 27, it's minus 31. Approximately, it's a difference of 10 raised to power 4. right? So that is why we say that mass of electron is very, very small. That's why mass of electron is negligible. That's the reason whenever we calculate whenever we calculate mass, number or atomic mass, we only take protons and neutrons, not the electrons, right? Okay, chal. Now, let us talk about the cation. Cations are, we know that, lose the electron, right? Positive charge will be there. That is the reason, what you need to know, number of electrons, right? We know that number of electrons, you have taken out the electron here. So that is why proton minus the charge. For example, I am saying M3 positive, right? I am saying that in this M you have 10 protons. So number of electrons will be 10, because I know that in the neutral atom, number of electrons and protons will be same. So it will be 10. Because it has lost 3 atoms, 3 electrons, it will be 3 and answer will be 7. Okay. But if we're talking about an anion, in anion, there is gain of electron. That is why you are going to add the charge over it, right? Whatever charge it is there, right? Okay. Chal. Now guys, let us talk about this thing, that mass of one atom. Why we say this, everything I'll tell you, right? Okay. So if we talk about mass of one atom, basically I'll be teaching you atomic mass unit now. Okay, so let's understand atomic mass unit in a very quick way, right? So atomic mass unit, guys, mass of one atom, I told you that mass of one atom is dependent on the neutron and proton, not on the electron. So that means I will just add on neutron plus proton, right? Okay, so here I have added mass of one neutron, right, multiplied by number of neutrons plus mass of one proton multiplied by number of protons, right? Now, if I say that this is Mn, this is Mn, why? Because mass of neutron and protons are approximately similar only. So I'll take that in common. It will be number of neutron plus number of proton. Now tell me number of neutron plus number of proton. That I was telling you A. This is nothing but A, that is the mass number. That is the mass number. A mass number will define the number of neutrons plus number of protons. That means, can I say that mass of one atom is equals to mass of neutron multiplied by mass number, right? So here mass of one atom is equals to mass of protons or neutrons multiplied by mass number. You have to remember this thing, right? Okay. Now with this thing we will see how AMU, beta, they can ask you some random question or AMU, right? Okay, some theory based question here. Now mass of one atom, if I put the value here, mass of one atom is equals to mass of proton and neutron. If I put the value here, mass of one atom is equals to mass of proton and neutron is what? It is 1.6 into 10 raised to power minus 27 grams. I have put the value here, right? Now just understand one thing. This 1.6 into 10 raised to power minus 27 gram, it is only called one atomic mass unit. That's the reason when I talk about mass of oxygen, what do you have to tell me? Number of protons plus number of neutrons. This is what? Number of protons, right? Number of protons plus number of neutrons. You just have to add it. If I ask you what is the atomic mass? What is the atomic mass of nitrogen? Ma'am, it has 7 neutrons, it has 7 electrons, it has 7 protons, 7 plus 7, 14, 14 AMU. AMU means this thing what I am writing here, 1.6 into 10 raised to power minus 27. Okay, got it, right? Okay. Is it looking little weird to see? Wait a minute, let me just decrease the brightness here. Now is it fine? Okay. Don't worry, just this slide is with this blackboard kind of background. Others are completely jet black only. Okay, others are completely jet black. Okay, chalo. Now, mass of one atom is equals to mass number into AMU. That is why oxygen atom is 16. 16 means number of neutron plus proton. Now, nitrogen means number of neutrons plus proton. Okay, that's why we tell all these things. Now, next important thing is mass of one atom is equals to A into AMU. So if I have to tell that mass of 1 mole of atom, very important, mass of one atom is A into AMU. Mass of 1 mole means 6.022 into 10 raised to power 23, right? So I will multiply this with the Avogadro's number. So mass of 1 mole of atom is equals to A gram per mole. Ma'am, what do you mean by this? You were to telling, ma'am, we have to multiply this. You have not multiplied, you to just have changed the, ma'am, you have just changed the units here. That means if I say that mass of one oxygen atom is 16 AMU or U, then mass of 1 mole of oxygen atom will be 16 gram per mole. That means the numeric value of atomic mass and 1 mole of mass is going to be exactly same. It's just that the units will change. Okay, only the units will change. Reason being, if we say Na is equals to 1 by AMU. If you want to calculate that, you can calculate that. Use a calculator. Pick out a calculator and just do this thing. 6.022 10 raised to power 23. Answer will be equals to 1 AMU. That is 1.6 into 10 raised to power minus 27 grams only. Right? So this is nothing but this is reciprocal of Avogadro's number only. Right? So that is why we say that we know that Avogadro's number is equals to reciprocal of 1 atomic mass unit. That is why here we have put in place of this, we have put this is if you multiply this by 1 by Na, here we have 1 AMU. These two will cancel each other and hence you will have gram per mole over there. Right, so that is the reason we say that numeric value is same. It's just that the units will change here. Right, same is with ma'am. What is gram atomic mass? Beta, listen to this. Gram atomic mass is same. It is the mass of 1 mole of that atom. Gram molecular mass is the mass of 1 mole of that molecule. Ma'am, what is molar mass? Molar mass is also mass of 1 mole of that atom or molecule. All these things are same only. Or if they directly write you what is the mass of 1 mole or what is the mass of Avogadro's number of atom, that is also the same. Right? Okay. So don't get confused here. Okay. Don't get confused here. Beta, okay. I'll just tell you here. So basically what I want to say that if they ask you mass of what is gram atomic mass? Gram atomic mass. It is also of 1 mole. Gram molecular mass is also of 1 mole. Gram molecular mass is also of 1 mole. Molar mass is also we are talking about 1 mole only. Right? Molar mass also we are talking about 1 mole only. Here in all these cases we talk about 1 mole only. Right? Or I can also write one thing here, that is even if they ask you what is mass of Avogadro's, mass of Na atoms or molecules, right, that is the same thing. Okay, same thing is applied here, right? And important thing is that the numeric value, if they ask you mass of 1 atom or molecule, then also numeric value will be same. If I say this is X, 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 then this will also be X. Here you will have gram. Okay? If I am talking about 1 atom, if I am talking about any molecule, that is water, here it will also be gram. Here because I am talking about mole, it is the same thing, but you will see gram per mole here. Because here we are specifying that 1 mole. Here also we are talking about 1 mole only. That's why students get confused. Okay, mass of Na, it's simply this much only. We are talking about 1 mole only. Gram per mole, or even if you write gram, that is also okay. Here you have to write AMU or U. Got it? Yes. Chalo. Yes, beta. We will do the questions. This is the same thing, beta. Mass of oxygen atom is 16. Mass of 1 mole of oxygen atom is 16 gram. Mass of 1 molecule of O2. 1 molecule will be 32. 16 into 2, 32U. Mass of 1 mole of O2. 1 mole means it is going to be same, that is 32. You will just have to change the units here. That is gram. Here you can write per mole. Okay. So that was the important part. Next is let's talk about isotopes, isobars, isosteres, isodiaphers, all these things. Right? Chalo. Now let us talk about these things. If you talk about isotopes, okay, if you talk about isotopes, Now let us see the isotope, same number of atom but different mass number, right? What questions they can ask you here, right? It will have the same protons and the mass number is different. That means number of protons plus neutrons is different. If this is the same thing, if this is same, that means can we say that in isotopes number of protons are same but number of neutrons are different? Okay, so that is an isotope. If you talk about carbon 12, 13, 14, oxygen 16, 18, these are the isotopes. Okay, now what they can ask you one more thing, that is physical property same here or chemical property same here? This they can ask you. So you just have to do, they can ask you which of the following statement is true regarding isotopes, right? In that way they can ask you this kind of question, right? This is the pattern of JEE, right? So that's what I'm telling you. Simple questions are asked in that kind of format. Which of the following statement are true? Which of the following, write the incorrect statement out of this. How many statements are incorrect over here? These kind of questions. So same chemical but different physical properties you will have, right? Okay, chemical properties will be same, physical properties will be different. Now they can ask you the average atomic mass here. Average atomic mass is nothing but the abundance of that particular isotope multiplied by the mass of that isotope divided by 100. That is going to be the value. So if I talk about, for example, there is an element X. It is 25% abundance for X isotope, 75% abundance for isotope having Y mass number, right? Mass, right? So it will be 25 into X plus 75 into Y divided by 100. That is going to be the value for average atomic mass for that isotope. Okay. Now important thing is, heavier isotope are radioactive, right? Okay, heavier isotope are radioactive elements here. If you talk about heavier isotopes, right, which has a lot, like big mass number, they will be radioactive in nature. Okay, now next is, what is isosters, what is isobars, isotones, isoelectronic, isodiaphers, all these things, right? Okay. This I'll also explain you in detail when we will do structure of atom. Now I will explain you these two things in detail. Okay, chalo. Now just have to go through the definitions here. Isobars are opposite of isotopes. That is same mass number but different atomic number they will have. Same mass number but different atomic number. That is number of neutrons plus proton is same but different protons they will have. Right? Okay, different protons they will have. Next is isotones. It has N over here, so you can say number of neutrons are same. Number of neutrons are same here, right? Okay. Isoelectronic means number of electrons are same. Iso means same thing. That's why I'm telling you what is same thing here. Isodiaphers, right? Isodiaphers means neutron minus proton. That means N minus P is going to be same. Isostar means number of electrons and atomicity is going to be same. Okay, number of electrons. Here I'll just specify this thing, number of valence electrons. Number of valence electrons and atomicity is going to be same here. Okay, number of valence electron, you can just write number of electron and atomicity is going to be same here. Now I'll just show you here only. Let's do the question here only. Chalo, I think that's it. Do you want to do isodiaphers? Here only I have seen that. Just give me a minute. Okay. So guys, this was basically isodiaphers and isosters that I was talking about, right? What is isodiapher and isosters? Because isotopes, isotones, these are very basic. This they will ask you, they can ask you some theory based question out of that. But they will not ask you a specific question from that. Specific question based on which of the following is isotope, which of the following is isodiapher, which of the following is isoster, from that they can ask you, right? So isodiapher means when A minus Z are different and proton is also different, but A minus 2Z is same. Okay, this is the exact thing that you need to see. Okay, is the exact correct definition. That is A minus Z is different, P is different, proton is different, but A minus 2Z is same. So I'll just give you the example here. Very important example. Now in this example, as you can see, right, okay, this is thorium. A minus Z, that means 274 minus 90, it is 144. Here also A minus Z is 238 minus 90, that is 146. That means A minus Z is different. But if you talk about A minus 2Z, it is going to be 234 minus 180, that is 54. It is 238 minus 184, that is 54. That means A minus 2Z, very rare examples here. You just see this example, that is the example they will give you in the exam, right? Okay, so A minus 2Z is same, that means it is isodiapher. Now, isostar is very, very interesting, okay? This one is very interesting, right? You're going to have fun solving this thing, right? If you talk about isostar, okay, isostar. In isostar, you have to see few things here, right? First is that number of atoms and number of valence. I told you there, na, atomicity. That means number of atoms, atomicity, and number of valence electron is same, right? Okay. They should have similar size as well, right? Okay. So if you talk about CO, N2 and Cn, yes, they all have atomicity 2. Right, number of atoms are 2, 2, 2, 2 everywhere, right? Okay, number of atoms are 2, 2, 2, 2, 2, 2 everywhere, okay? Now, if you talk about CO, we have to see the sum of valence electrons here. Carbon, bacha, carbon is what? Carbon is hydrogen, helium, lithium, beryllium, boron, carbon, right? It is basically, you can say 2 and 4, right? 2 and 4. Oxygen is atomic number 8. So it will be 2 and 6. So what is the valence electron, guys? Valence electrons is in the outermost shell. So if you also want to know, if you also want to write the electronic configuration, you can write 1s2, 2s2, 2p3. 1s2, 2s2, wait a minute, 1s2, 2s2, 2p2. This is for carbon. This is the valence electron, right? So that means valence electrons are 4 here. Valence electrons are 6 here. Okay, now let me know that, ma'am, total number of valence electrons will be 4 plus 6 equals to 10. Acha. Now I want to see that if you are able to solve this for nitrogen, right? This is nitrogen. For nitrogen, it is 1s2. Okay, if you want me to write full configuration here, 1s2, 2s2, 2p3. This is the valence. Okay, so it will have 3, 4, 5 valence electron. That means other nitrogen will also have 5 valence electrons. So total valence electrons will be 5 plus 5 equals to 10. Remember, it also has 10, right? It also has 10. Okay, what about this one? What about this one? Carbon and nitrogen. Carbon, we know that it has 4 valence electron. 4 valence electrons. I'll just write the valence electron, or you can just write this thing here. 2s2, 2p2. This is 1s2, 2s2, 2p3, right? So it is having how many valence electron? It is having 4. It is having 5. Ma'am, here electron is coming out to be 4 plus 5. Ma'am, it is 9. But here it has also gained 1 electron here. So it will be 1. So answer is going to be 10. So again, it is definitely an isostar, right? So CO, N2, Cn negative, these are the examples of isostar. Is that clear to everybody here? Is that clear to everybody here or not? Yes, students, is that clear to you or not? Everybody in the comment section. Everybody in the comment section, is that clear? Hanji. Chalo. Now, let's talk about, wait a minute. Let's talk about mole. Okay, now beta, I am going towards mole concept. I'll just tell you what is mole concept. After that, because the all question will be based on mole concept only, right? So mole concept is basically 1 mole. We know that how many particles? It is Avogadro's number of particles, 6.02 10 raised to 23, right? Avogadro's number, it is called, it is mentioned by Na. So that means with 1 mole, we have 3 things here, okay? 3 things. So whenever we are calculating the number of moles, we will calculate it by 3 methods. First is given by molar mass, right? Always it will be given by molar, given by molar, given by molar. If you talk about mass, it will be given mass by molar mass. If you talk about volume, it will be given volume by molar volume. If you talk about particles, it will be given particles by molar particles. And how many particles you have in 1 mole? You have Avogadro's number of particles, so that's why we have written Na here. 1 mole, not 1 mole, if you talk about the molar mass of 1 mole, right? Okay, that is called molar mass. Okay, if you talk about the mass of 1 mole, that is called molar mass. So that's why we have written molar mass here. So eventually it is going to be given by molar, whether you talk about mass or you talk about volume or you talk about particles. From these 3 things only, we are going to solve all the questions of some basic concepts of chemistry. Even limiting reagent is based on this. Stoichiometry is based on this. Equivalence concept is based on this. Everything is based on this thing only. Right? Okay. Chal. Now, some things here that if you have 273, this is very, very important for JEE mains, right? 273 Kelvin temperature, 1 atmospheric pressure, this is 22.4 liters. What is a molar volume? If they give you nothing, then you will take 22.4 only. If they give you nothing, like they just say that, okay, it is STP. They have not mentioned which standard temperature pressure, right? So in that case, you will take it as 22.4, that is taken as standard. But if they have specified that we are talking about 273 Kelvin and 1 bar pressure, in that case, you will take it as 22.7 liters, right? Very rarely, but yes, they can give you that. If they give you 25 degrees Celsius temperature or 298 Kelvin temperature and 1 bar, then you will take 24.8 liters as the molar volume. Okay, understood? Right? Okay, chalo. Got it? Now, guys, this is the question, only question. So, I will do. Hai na? Okay, questions. So, we will do. Achha, there is 1-2 things that I need to teach you with the help of question only. Right? That will help you with the questions. Right? Okay. Now, just go through this. Again, just explaining you the trick of solving mole concept, because the problem with mole concept is that we don't have any as such formulas here, right? We have to use unitary method here. So many things we have to use here, tricks here. So that's why, right, you have to follow a proper method of solving these questions, okay? So what is going to be your method? So this is a very simple number of atoms in 7 gram of potassium. They have given you mass here. Of potassium, they are asking you number of atoms. So always and always and always, okay, tell me one thing. Who is a mother? Achha, tell me one thing. Do you love your mom? I to love my mom, right? Tomorrow is her birthday, right? That's why I'm so excited, right? So do you also love your mom? Everyone loves their mom, right? So mother is a bridge, right? So when you want to ask your father about something, what you will do? You will ask your mother. You will say, Mama, I want this. Please, can you just ask Papa about this? Then your mom will go to your father, then request them, okay, please, the kids are asking, hai na? So mom will be like that bridge, right? So here, what is mom? Who is mom? Moles is the mom. So always and always you will go through moles every time, every single time you will go through mom, right? That is moles, right? You have to ask the mother, you have to go through mom. Right? So if they are asking you anything, they have given you anything, you will always calculate. First step will be calculation of moles. So you will calculate moles. Beta, if you follow this thing, your all question of mole concept will be very simple for you. First, you will solve the moles here. I have solved moles. After that, they are asking you, acha, atoms. Okay. Then we will put another formula. That is moles is equals to atoms by Avogadro's number. So it will be atoms, you know that. What is atoms? You can calculate atoms is equals to moles into Avogadro's number and you will get your answer here, right? Next is, ma'am, what if this kind of question is asked? Okay? These kind of questions when they are asked, how to answer these kind of questions, right? Okay, chal. Now, how many moles of HNO3 solution contain 0.5 mole of oxygen atom? Ma'am, here they have given us same potassium only, they have given us mass. They are asking only number of atoms from potassium only. But ma'am, here they have given us moles of oxygen atom and they are asking moles of HNO3. Ma'am, how to do this now? So see, firstly what you will do? First you will see what is asked to you. You will see that in the end, first you will see what is given to you. right? Maybe volume is given to you, maybe mass is given to you, maybe particles is given to you, it doesn't matter. Whatever is given to you, they have given you volume, they have given you mass, they have given you particles, whatever is given to you, you will firstly calculate the number of that thing to which given thing is given to you, right? Whatever is given to you. So here for oxygen atom, they have given me moles. So already moles is given, so no tension, right? What if they don't give me the moles? I'll calculate the moles. After that, I will apply unitary method, right? And I'll see, here I know that one molecule of HNO3 contains 3 oxygen atom. So I'll apply the unitary method here, right? That okay, 1 mole of HNO3 has 3 mole of oxygen atoms, right? So if you have 0.5 mole, how many moles of HNO3 will be there? With that, you will calculate the moles of HNO3, whatever is asked to you. Then, if they are not asking you the here, so they are asking you directly the moles. What if they are not directly asking you the moles? Then what you have to do, you just have to apply that formula, right? Moles is equals to, okay, they are asking you volume, then it will be given volume by molar volume. Molar volume, you already know. What if they have given you, asked you mass? Mass by molar mass. Molar mass also you know for HNO3. What if, ma'am, they have asked me particles? Particles is also number of molecules divided by Avogadro's number. Avogadro number also you know what is the standard value, right? Okay, got it? So the same thing that I have done here, right? Firstly, number of oxygen atom moles is this one. Number of moles of oxygen atom is this one. Then I applied the unitary method that 1 mole of HNO3 has 3 mole of oxygen. That means 3 mole of oxygen has 1 mole of HNO3. That means 0.5 mole of oxygen will have 0.5 by 3. Right? If this is the number of moles of HNO3 that I will get. Got it or not? Right? Okay. Yes, everybody got it or not? Okay, so from here you can calculate mass, volume, anything you can calculate. Okay, so that was a simple thing where you can just put that thing, right? And relation of mass, weight, number of moles, AMU, tell what actually definition means or what is solving when solving question. Okay, natures, definitely I'll do that. Okay. Now, ideal gas equation. Now, beta, what is ideal gas equation? PV is equals to nRT. From here, you can just learn this particular PM is equals to DRT. PM is equals to DRT, right? PM is equals to DRT. Okay, understood? Chalo. Now, you just remember PM is equals to DRT. From here, if you don't want to remember that, basically it is N is equals to number of moles, weight given mass by molar mass, right? It will jump here, weight by volume. Weight by volume is nothing but density, so it will be PM is equals to DRT. P is the pressure, M is the molar mass, D is the density, R is the gas constant, T is the temperature, right? Now, next question is, ma'am, what is the value of universal gas constant for different things? So, if you talk about universal gas constant, if you talk about joule per mole per Kelvin, the value will be 25 by 3. Beta, this is very important. Okay, this is very important. If you're talking about joule per mole per Kelvin, right? Okay, that will be, array, I am not teaching you states of matter. It's just the thing that you required. If you think that this is ma'am, this is just an initial stage of states of matter. This is required throughout your chemistry, physical chemistry, right? So it's 25 by 3 joule per mole per Kelvin. If you talk about in Kelvin, you want to calculate, so it will be 2 Kelvin per mole per Kelvin, 2 calorie per mole per Kelvin. If you talk about in liter atmospheric, so it will be 1 by 12 liter atmospheric per mole per Kelvin. So these are 3 very important values, very important values required throughout your physical chemistry, whether you talk about equilibrium, you talk about chemical kinetics, anything, right? Thermodynamics, electrochemistry, this will be required everywhere, right? Okay. Now, remember this one more thing, this relation that PM is equals to DRT, or you can say D is equals to PM by RT, right? D is equals to PM by RT, right? Okay. Now, here, if you talk about density is directly proportional to pressure and pressure is inversely proportional to the temperature. Okay, just remember this thing. They can ask you a question based on this. Next is vapor density and molar mass, right? Just remember this result, that molar mass is equals to 2 into vapor density. Sometimes they will not give you the molar mass, they will give you the vapor density. What you have to do, just multiply it by 2, you will get the molar mass. Just remember this thing, how it is derived. Vapor density is equals to molar mass of gas by molar mass of H2. Molar mass of H2 is nothing but 2. So we have this result here. It's a very, very important and very, very simple result which is required. Okay, which is very, very important. Okay, chalo. Now, next is law of chemical combination. So law of chemical, let's go through the laws of chemical combination. If we talk about the first law, that is law of conservation of mass. It is, that means mass is equals to reactant. Mass of reactant, all the addition of the reactant is equals to mass of all the products there, right? That means number of atoms on reactant side is equals to number of atoms on product side. That is why whenever you are solving the questions of mole concept, you require balancing, right? That is why balancing is required everywhere whenever you are solving the question of mole concept, because our chemistry is made that way, right? Okay, chemistry is that way only. You have to, like, everything should be constant there, right? Law of definite proportion means that if you take that compound from anywhere, you take water from a tub, you take water from the lake, you take water from some nala, you take water from anywhere, right? Water is going to stay H2O only. Water is not going to become H2O2. It will stay H2 only, right? So that is law of definite proportion, that a compound will always have that particular molecular formula no matter what, right? Okay. Oxygen in India, though it is very polluted, but still it is O2 only, right? Okay. Though we have so many impurities in it, but we are inhaling O2 only, right? It's not like oxygen in India is only oxygen O, and oxygen in America is O3. It's not like that. And oxygen in Europe is O4. It's not like that. Oxygen is O2 only, right? Okay, chalo. Law of multiple proportion. Now, law of multiple proportion means I have two elements, carbon and oxygen. Let's take an example. I have carbon and oxygen. Now, I am saying that it is forming two different compounds. It is forming carbon dioxide and carbon monoxide, right? Now what they are saying, you can fix, what I'm saying, fix the mass of one atom. This is also CO, this is also CO. Okay, both are containing carbon and oxygen. I'll fix the mass of one element. I have fixed the mass of carbon and carbon here. Now, the ratio in which the other two elements are existing is in simple whole number ratio. That means oxygen and O2, they will have 16:32. That is 1:2. That is simple whole number ratio. That is law of multiple proportion. Ratio of atoms in the simple whole number. Okay, got it? Right. Okay. Now, next is Gay-Lussac's law. Now, Gay-Lussac's law means you have this particular reaction. Now, what they are saying, this X and this Y, right? They are in simple whole number ratio, right? In which two elements are combined together to form a compound. These two elements will combine together in a simple whole number ratio. Very simple laws, yaar. Very simple law. They can ask you a very simple question based on this law. Which of the following is true? Statement based question can be asked if they ask, right? Okay. Now, what is reciprocal? Now, this law is important because usually students skip this law. That's why I'm saying that this law is important. Other laws are very basic. These are all basic laws, but this is important law. Now, this is important to understand this law with the help of an example. Now, they are saying you have three elements, right? Three atoms you have, right? And one atom out of it, let's say it's oxygen. It is forming two compounds with those two different elements. That means oxygen with sulfur, it is forming one compound. Oxygen with carbon, it is forming one compound. With carbon, it is forming carbon dioxide. With sulfur, it is forming sulfur dioxide. Okay, right. Now, they are saying these two, if I just eliminate the common atom here, that is if I eliminate the oxygen here, the remaining element will combine together to form one compound, that is carbon disulfide. Okay. Now, what they are saying that If you take the ratio of this, that is 12:64, that will become 13:16. This is a simple whole number ratio. Okay, so they're just saying that two elements that are forming a compound together, right? Okay, two elements that are forming a compound together, and they're also forming the compound with some specific element like oxygen. When they combine together, they will combine together in the form of simple whole number ratio. Okay, right? Chalo. Now, next is Avogadro's law, very, very simple law. This means that it doesn't matter which element, which gas you have. If same amount, that means volume of two gases is same, then the number of molecules will be same and number of moles will be same. So, for example, if I take about H2 and Cl2, right, these two gases I have, it doesn't matter because they are different. But if I say that here the volume is, let's say here the volume is x liter, है ना? Here the volume is 2x liter. Now, because the volume is doubled, that means the number of moles will also get doubled. Number of particles will also get doubled, right? Here, if you say n is the number of particle here, 2n is the number of particle here. If I say here this is x liter, then number of particles will be same, number of moles will also be same. If I say this is 3x, if I say this is 3 liter, 3x liter, right? That means number of particles will be tripled, number of moles will also be tripled. Got it? So this is the whole law of chemical combinations. Okay, beta, got it or not? Next is stoichiometry, limiting reagent and empirical formula. Three important topics we are going to do. Right? Okay, chalo. Chalo. Now, stoichiometry. Okay, now what is the stoichiometry? Guys, stoichiometry simply means the number of moles that you will have over here. This is called nothing but stoichiometry. Okay, now if I talk about the stoichiometry, you have to understand one thing. If I say this is 2, this is 1, this is 2. First, you have to understand what does this means. Okay, it means that it is 2 mole of SO2 react with 1 mole to give 2 mole of SO3. Okay, why balancing is important? It also means that 2 molecule of SO2 reacts with 1 molecule to give 2 molecule of SO3. It also means that 2 into 22.4 liter gives 22.4 react with 22.4 liter to give 2 into 22.4 liter of the volume of SO3. It also means that 2 into molar mass of SO2, molar mass of O2, when they react together, they will give 2 into molar mass of SO3. Ma'am, what do you mean by that? This is nothing but mole concept, right? So here I was telling you the same thing throughout. If I say this is mole, this is mole, this is mole, if I have to write it in the form of one molecule, I will write it like this. If I have to write it in the form of Avogadro's number, then I'll write it something like this. 2 into Avogadro's number, 1 Avogadro's number, 2 into Avogadro's number. If I have to write it in the form of volume, because number of moles is what? Given volume by 22.4. So number of moles will be number of mole multiplied by 22.4. That will become the volume here. Okay, so volume is this one and this one. If you talk about the mass is number of moles multiplied by the molar mass, number of moles multiplied by the molar mass, number of moles multiplied by the molar mass. That is called the mole concept applied in stoichiometry. Got it? From one reaction, how you can tell different things. Beta, tell me if that is clear to all of you or not. Bacha, tell me if that is clear to all of you or not, because this is a very important concept, right? Very important concept. Usually students don't see the concept directly. देखो बेटा, question तो is very important. Only theory, you will not do anything with only theory in physical chemistry. But also if you don't understand the theory part like this, then you will not be able to, you can't do all the questions, right? Okay. So you can't predict what kind of question they will ask you. Srikar, organic today, I'll watch previous year 5 days, it will be enough to score. Shrikar, yes beta, bilkul it will be enough. Okay, now you have that much time only, so that will be enough. Right? Okay. Now you don't have any other option, na? I can't extend, I am not a magician, right? So who can extend your timeline? Now, January will happen maybe next year. No, January will happen. Just God, please delay this 21 days, make it into 3 months so that students can prepare well, right? I can't do that. I can just tell you how to do things in that limited time, right? Okay, so that is the thing for stoichiometry. Okay, right? हाँ beta, हाँ, just this one I am using this, right? Okay, now let me just show you. I think now let's talk about the limiting reagent, right? Okay, let's talk about the limiting reagent. What is basically a limiting reagent? A limiting reagent is the one which is in limit, right? That means, for example, you have a lot of sabzi, right? Okay, but that you had only 2 chapatis, right? But you have a lot of sabzi. Now what will happen, right? The sabzi will left remaining, right, in your katori, right? Basically what I want to say that, for example, you have a lot of you have 35 idlis, but you have only this much sambar, right? So that means sambar is the limiting reagent here, right? Because you don't have enough sambar. Idlis are 35, there is only one katori of sambar that you have, right? So that means the sambar is not enough. What if you have this much sambar, right? Full like this much sambar, but you have only 2 idlis. Now, idli will be the limiting reagent. So, same way we will say that which will be left remained after the reaction, right? So, basically, guys, to clear that up, I'll just tell you the direct method of solving this, right? I'll just tell you the direct method of solving this, how you have to solve these things. For example, this equation is given to you. Now, understand this simple trick here. One is given, one is stoichiometry. Stoichiometry means from the reaction only. From the reaction, I know that it has 1 mole, it has 3 mole, right? But given to me is that it is 20 and this is also 20. Beta, understood or not? This is also 20 and this is also 20. This is, suppose this is given to me in the question, right? Okay, right? So 20, it is given to me in the question that you have 20 moles of N2, 20 moles of H2, which will be the limiting reagent, right? So how to do this in a quick way? Just remember G by S, G by S, GS, GS, GS. Okay, GS, GS, GS. Now what is this? Katori's test tube. Space in the stomach is also important, ma'am. Yeah, that is basically your catalyst. Okay, so now this is 20, this is 20. Just remember G divided by S, that is 20 divided by 1, 20 divided by 3. Now, out of this, which will be the lowest value, that will be your limiting reagent. Okay. Now, because this is a lower value, so this is going to be limiting reagent. Next is, if they ask you the formation of product, product will always depend on the limiting reagent. Always it will depend on the limiting reagent, not on the excess reagent. For example, here, this is the limiting reagent. That means limiting reagent we have 20. So that means corresponding to this 20, right, you will have the formation of the product. We can say that 3 will form 2NH3, 3 mole will form 2NH3, 1 mole will form 2 by 3 NH3, then 20 will form 2 by 3 into 20 NH3. Got it? So this is how the product formation will depend on the limiting reagent, not the excess reagent. If you actually want to have a good dish, now it will depend on the idli, na, how much sambar you will eat. If you are a big fan of sambar, then you will eat it. Ma'am, we don't have idli, but still we will eat sambar. Right? Okay. Chalo. Now these are the question only. This question we are going to do differently. Right? So that's why I'm just erasing this here. I'm just giving you some I think 4 or 5 more slides we are left with. Right? Okay, let's do this quickly. Acha. Now the next formula is percentage purity. Percentage purity, guys, this means 3-4 purities we have. Percentage purity is mass of element in question, what is given in the question, is equals to mass of pure element plus the impurities. If they give you that this sample is impure, right? Mass of 50 gram of sample is impure and impurities they have given you, this much impurities it has. So that means the mass of element in the question that is given to you, the full mass is given to you, that will be mass of pure plus impurities. So how do you calculate the percentage purity? We have to calculate the purity. So it will be mass of pure element divided by mass of element in the question, because this will have purity plus impurity. Got it? This will be purity plus impurity. It's like you have a bucket, you have some white balls and you have some red balls So you want to calculate how many white balls you have. What you will do? You will say number of white balls divided by total number of balls multiplied by 100. Same thing I am doing here. It will be mass of pure. They are asking you the percentage purity. So it will be mass of pure element divided by total mass of element, that is purities plus impurities. Okay, got it? Chalo. Now, next is percentage yield, right? Percentage yield is a different concept as compared to percentage purity. There is no relation here, right? Percentage yield. Here we have two things. One is the experimental value, one is the theoretical value. This is usually, we do this in labs, right? This can be used in like physical chemistry. They can ask you, especially in some basic concepts of chemistry, they ask you this thing, right? So experiment means what I am doing in the lab. That is the real thing that is happening. This is what my expectation is. Now what you will see in the theory books, right? Yeah, it is yield, right? Now, in the books, in the lab manuals, you will see that, okay, they have given you that approximately this value you will get. That is the theoretical value that they are assuming, right? But always and always, right, if you have actually done your experiment in the right way, you will always have error, right? Okay, so no experiment is 100% accurate, right? So that's why experimental is the reality, theoretical is the expectations. Now they're saying what is the percentage yield? That is what I have calculated in the lab divided by what is written in the theory. So this theoretical will be given in the question, right? Okay, or they can just give you, calculate in the question by stoichiometry, right? Okay, so this you will calculate in the question by stoichiometry. They have written it here, then why I am writing it here? Calculated in the question by stoichiometry. Okay, beta, this you will calculate with the help of stoichiometry. That okay, they will give you that this much reactant you had, how much product is formed, this and that they will give you with the help of mole concept, right? You will calculate the product formation, right? That is your theoretical value, right? That is your theoretical value which you have just written it in the like theory, right? In your sheet you have written it, okay, this is it, this much calculation should be there. Now, what is the experimental value? This they will give you directly in the question, right? Okay, that I was in a lab, I calculated this thing from the experiment, right? Okay, so that will be given in the question. This is how you will calculate the percentage yield. Okay, right? Okay, beta. Chalo. Then there is what is minimum molecular mass. Minimum molecular mass simply means atomic mass divided by percentage of element multiplied by 100. Right? Okay. For example, they are saying what is the minimum molecular mass of oxygen in water. So firstly, you will calculate the percentage of oxygen. Percentage of oxygen is going to be total it is 18. Here it is 16. Okay? 16. This is 100. This is going to be the percentage of element. Percentage of oxygen. Atomic mass is what? Atomic mass divided by percentage of element multiplied by 100. That is going to be the answer. This also they can give you in the question. Sometimes they will give you directly in the question that what is the percentage of this particular element, right, in that compound. Okay, right? Okay, ji. But examples I'll give you only. Okay? In the question you will get all the examples, right? Last concept is empirical formula, I think so. Yes. Then we have concentration terms only, right? Okay. Concentration terms then we have. Then we'll focus on the concentration terms. Acha. Now, beta, if you talk about the empirical formula is the simplest ratio, right, of that molecular formula, right? So if I talk about glucose, if you divide all of these things by 6, right, you will get CH2O. This is the empirical formula. This is the molecular formula. Now, what is the formula? What is the relation? Relation is molecular mass is equals to N into empirical mass. N is the division or multiplication that you will do here. Molecular formula is equals to that same N multiplied by the empirical formula, right? Okay. Also, you can remember that vapor density or you can say molar mass is equals to 2 into vapor density, because sometimes they will not give you the molar mass directly, right? Now, beta, understand one thing. Whenever you are doing any question solving here, you will make this table here. Okay, I'll explain you everything with the help of examples as well. Right, first, just go through this part because I'm quickly revising this. Right, so basically, you will make a table. Right, in the first column, you will write the atoms, that is carbon, hydrogen, whatever atoms is given to you in the question. Right, now then you will calculate the moles from here. Moles is what? Given mass by molar mass. Molar mass of this carbon is 12. What is the given mass? Given mass will be either given to you, mostly it will be given to you in the form of percentage only. If they have given us, they have given us in the form of ratio, that is 9:1:35. So it is 9:1:3.5. So it is 9:1:3.5. Sometimes they will give you in the form of ratio. Sometimes they can give you in the form of percentage. Right, okay, so you'll just have to put that percentage or the ratio over here, right? Hydrogen is 1 molar mass, ratio is 1. Nitrogen is 14, ratio is 3.5. There you will calculate the simplest value here, right? From that simplest value, you will see that how can I make it in the simple whole number ratio. If I multiply this by 4, if I multiply this by 4, then it will become 1, it will become 4, it will become 3, right? So it will be C3H4N. That will become my empirical formula, right? That will become your empirical formula. Beta, just these 3 tables you have to remember. Atoms, moles, percentage or ratio or mass will be given to you divided by atomic mass. Simple whole number ratio you have to calculate there. From there, you just have to apply these 2 formulas. Just like here you had empirical formula is this. Acha, from empirical formula, you can calculate the empirical mass also. Just put the values here, you will get the empirical mass. Molecular mass or vapor density will be given to you in the question. They have given you molar mass. So it is 108. You will just put the value here. Molar mass is equals to N. You will calculate the value of N here. We know that there is one more formula, that molecular formula is equals to N into empirical formula. Now, in that empirical formula, put the value of N here, you will get the molecular formula here. Okay, got it? Right? Okay, chalo. Now, last is, it's not the session ka last, it's basically just your revision last thing, right? Okay. Now, beta, we have concentration terms. Concentration terms are percentage composition. So, I'll just tell you quickly that how concentration terms are done. So, concentration terms, if you talk about the percentage here, right? If you talk about the percentage composition, so basically they are in weight by weight, weight by volume, volume by weight, volume by volume. Anything can be given to you. Remember one thing, always it is going to be solute by solution multiplied by 100. Always and always. Now, if they have given you weight by weight, it will be weight of, now always remember one more thing, that 1 we will mention for solvent, 2 we will mention for solute. It is already written there. 1 we will mention for solvent, 2 we will mention for solute. Always and always remember that, right? Okay. It's not like you should do this only. It's like I have written the formulas like that. Okay, so if you want to remember these formulas, then you have to remember like that. Okay, now, and mostly in the books also it is written the same way, right? Weight by weight means weight of solute divided by weight of solvent. Weight of solute divided by weight of solution. Solution means W1 plus W2. That is solvent plus solute. W by weight. Weight by volume is weight of solute by volume of solution multiplied by 100. V by W, volume of solute by weight of solution multiplied by 100. V by V, volume of solute by volume of solution multiplied by 100. Next question is, ma'am, what is the units here? Units of weight will be in grams, unit of volume will be in milliliters. Beta, these are the very little things that will be very helpful for you, right? Very helpful for you in your exam, right? So weight is, see, on basis of two things the questions are usually asked from this topic, from this chapter. One is mole concept, stoichiometry. Other is this concentration terms. Okay, so it is in milliliters. Next is how to decode this thing. Now, decode you need to understand. Decode means if I am saying that 10% of ethanol solution, aqueous solution we are talking about, that means water we are talking about. That means what I want to say, that 10 gram of ethanol in 100 gram of water, because it is W by W. That means 10 gram of solute I have in 100 gram of solvent solution. So it will be 10 gram of ethanol in 100 gram of what ethanol solution, or you can just write here instead of water you can write here ethanol solution. So you can say the weight of water solvent will be solution minus 10, that is 90 gram. So 10 gram is the weight of solute and 90 gram is the weight of solvent, that is water. Okay. Now if you talk about weight by volume, we can say that 10 gram of ethanol in 100 milliliter of ethanol solution. Ethanol solution. Okay? Ethanol solution. Understood? Right? Chalo. Next is decode. How to decode this thing, beta? If you have volume by weight, so you will say 10 milliliter of ethanol in 100 gram of ethanol solution only, right? Hai na? Ethanol solution. Ethanol solution. Here also write ethanol solution. Ethanol solution. Here it will be 10 milliliter in 100 milliliter of ethanol solution. So because units are same, that's why what we can say, volume of solvent is equals to solution minus 10, that is 90 milliliter. Okay. This will help you when you will calculate molality. From here, firstly, I'll teach you the definition of molality. Then we'll again come to this question after learning what is molality. Okay. Chalo. Firstly, let us talk about concentration terms of ppm. ppm means parts per million. Everything is same. Everything is same. Here, instead of 100, you will multiply it by 10 raised to power 6. That is the only difference. That's it. Because percentage means in 1 cent. Cent means 100. CENT, cent means 100. In 100 you are talking about. Here, parts per million. Million means 10 raised to power 6. So you will multiply this with 10 raised to power 6. Okay. Acha. Now, beta, let's talk about the mole fraction. Mole fraction is basically, if you talk about mole fraction in terms of, mole fraction I'm saying. Firstly, there is mass fraction, then you have volume fraction, then you have mole fraction. Okay. Let's talk about all these things. Okay. Now, if we talk about mass fraction, that is always that component divided by total number of component. So, mass fraction of 1 is weight of 1 divided by total mass. Mass fraction of 2 will be weight of 2 divided by total mass of all the components. Volume fraction is volume of that component divided by total number of components. So for 1 it is V1 by total number of volume, V2 by total number of volume for V2 for second component. Mole fraction means we are talking about moles. So this is the most famous thing that you will see. Okay? Mole fraction of 1 means number of mole of that component divided by total number. Mole fraction of 2 means number of mole of second component divided by total number of components. Right? Total moles of the components. Now, for example, you have n number of components. The mole fraction of all the components will be unity. Right? This is also a very important conclusion. Okay. Now, very important thing, that is what is molality and what is molarity. Okay. What is molality and what is molality? Guys, just 6 hours and 10 minutes left. Yeah. Okay, so what is molality and what is molarity? So molality, guys, everybody, molality is number of moles of solute divided by mass of solvent, right? If you talk about here, number of moles of solute divided by mass of solvent. Just remember this by Virat. Okay, so now you have Virat. Virat means V for volume, R for molarity, because in molality and molarity you just have the difference of L and R, right? So how to remember? Just remember this by Virat. That means V for volume, R for molarity, riti, R, molarity, not molality. Okay, so here it is molality. In molarity you have number of moles of solute divided by volume of solution, right, in liters. Here you have number of moles of solute divided by mass of solvent. Two things. Mass, here you have volume. Here you have solvent, here you have solution. I told you in ppm also, in percentage also, that weight will be in grams and volume will be in milliliters. But in this case, weight will be in kilograms and volume will be in liters. If you have written weight in grams, you will multiply this by 1000. If you have written volume in milliliter, you will multiply this by 1000. Right? Okay, chalo. Got it? Acha beta, last thing here, right? Okay, last page of the reaction of the apna, all the formulas here, right? The remaining formulas. Strength is equals to weight of solute divided by volume of solution in liters. If they ask you the strength, strength is very similar to molarity. In molarity, we write here number of moles of solute, but in strength, we write weight of solute. That is the difference between strength and molarity. Okay, now, if you talk about strength is equals to what is beta, these three relations are very important, direct relations you have to learn. Strength is equals to molarity into mass of solute. See, if you multiply molarity with molar mass of solute, if you multiply molarity with molar mass of solute, if you multiply this with molar mass of solute, we know that here number of moles is nothing but weight by molar mass. So it will cancel out and you will get the strength, right? So that is why direct relation is strength is equals to molarity into molar mass of solute. Molarity, density, weight by weight percentage, direct relation. Molarity is equals to 10 into density multiplied by weight percentage of solute, right, divided by mass of molar mass of solute, right? Next is molality. This is a very important relation between molarity and molality, right? Very important relation. That is molality is equals to 1000 m, that is molarity, divided by 1000 d, right, minus molar mass of solute into molarity, right? So that is the relation. Okay beta, thank you. Acha beta, now that was the revision, so I have already made the notes for you. Now we are going to solve the questions. So it's very literally freezing here. Let me just drink some water. Just give me a minute. Hanji students, everybody. Bacha, shall we start with the questions? Yes, students, shall we start with the questions or not? Everybody in the comment section. Shall we start with the questions of mole concept? Yes, bachcho. Yes, bachcho. Let me just see your energy over here. Yes, students, shall we start, everybody? Yes, ma'am, let's do it. Let's go, ma'am. Very good. Haan. Chalo. Ma'am, what is the temperature now? Yeah, temperature is, wait a minute, let me check. Just give me a second. Phone is also very cool. Temperature is not that much down. Temperature is 12 degree only, but I am feeling like it's 5 degree. Temperature is 12 degree, but it's very cold, yeah. It's like it's basically uh, when you have like cold breezes, it's cold breezes that I can feel right now. Chalo. Okay, chalo. Let us now start. Let us now. Ma'am, do you get snow, ma'am? Arey, nahi yaar. I don't live in hill station. I have never seen snow in my life. Acha, chalo. Now, let us see. First question, guys. First question. Okay, completely. Let's solve this. The number of units which are used to express concentration of solutions from the following is, out of the following which can express, beta, all these are your previous year questions. So let us solve this in next 30 minutes. Okay, in next 30 minutes we are going to complete the questions of mole concept, and after that we are going to jump to blackboard. We have everything else will be in blackboard only, right? Acha. Now, the number of units which are used to express concentration of solutions. Everybody, hip hip hooray. Hip hip hooray to our last day of 2024. Okay, chalo. I want all of us to complete 2 chapters today and enjoy it after that. Okay. I am not saying that after that all my kids will, everybody will be enjoying the new year and my kids will be there and they will be sad and depressed. No, I don't want you to feel that. Okay, we will complete properly 2 chapters today. After that, you will enjoy for 1-2 hours. You can enjoy. Take a chill pill, right? Okay, chalo. 333. Acha, mass percentage, that is the number of units which are expressed concentration solution from the following. Mole is not, mole fraction is also concentration only. Molarity is concentration, ppm is concentration, molality is concentration. 1, 2, 3, 4, 5. Totally you have 5. Okay, 3. Why? Which you have missed? What you have missed here? Beta, mass percentage, ppm, mole fraction, molarity, molality, all these are concentration terms only. Moles is not concentration term. ppm is also concentration term. Okay, ppm, you have missed ppm here. You have missed mole fraction also. Okay, so it is 5. Next is number of hydrogen atoms per molecule. Now they are saying, acha, first is I want to know how many of you know what, see, in mole concept, it is different. In some basic concepts of chemistry, the toughest part is, ma'am, which formula they are asking. Which formula, ma'am, which concept I have to apply. So now tell me, what is this concept? What is this concept over here that you can see? Right, okay. Number of hydrogen atoms per molecule of hydrocarbon. There is some hydrocarbon. Hydrocarbon will have one carbon name. That means it will have carbon and hydrogen. And they are saying that how much percentage of this you have 85.8 percentage, right? And they are saying molar mass is given to be 84. Okay. Number of hydrogen atom you have to calculate. That means molecular formula you have to calculate. Okay. If this is 80.58, 85.8, then what is going to be? Beta, I am waiting for your answers in the comment section. Which concept it is based on? Which concept it is based on? Which concept, beta? Ma'am, percentage of element. This is based on empirical formula, guys. Empirical formula. Right? This is based on empirical formula. Okay, empirical formula. Because they have given you the percentage. So it will be 14.2, right? 14.2 it will be. This is the percentage is given to you. Percentage means given mass is given to you. For carbon it is 12. For hydrogen it is 1. So you just have to make the simplest ratio here, right? Make the simplest ratio here. This is the moles. You can make the simplest ratio here. Then you will get the answer, right? Make the simplest ratio here, right? Then you will get the answer over here, right? So if you see this, this is percentage is given to you 85.8 divided by 12, right? So you will get 7.15, you will get 14.2. 7.15, 14.2. Can I say if I divide this by 7.15, divide this by 7.15, it will be approximately 2, it will be approximately 1. So can I say CH2 is going to be my empirical formula? Right? Empirical formula is, arey nahi, CH2 is going to be my empirical formula. It's not my molecular formula. It's not my molecular formula, beta. It's my empirical formula. Right? So I know that here it is basically 12 plus 2, that is 14. That is my molecular mass. Sorry, this is my empirical mass. Now, we know that molecular mass is equals to N into empirical mass. So, N is equals to molecular mass divided by empirical mass. So, N will be equals to molecular mass is what? Molecular mass is given to be 84, right? Empirical mass is 14. You will get the value of N as 6. Now, empirical molecular formula is equals to N into empirical formula. Empirical formula is CH2, so it will be 6 into CH2. Answer will be C6H12. This is the C6H12. This is the molecular formula. And here the answer is going to be 12 hydrogen atoms. Okay, answer is going to be 12 hydrogen atoms that you will have here. Okay. Beta hydrocarbon, they have not given us anything about it, na? Right? Okay. Hydrocarbon they have given, right? So if there was any oxygen or anything like that, they would have mentioned that here, right? A hydrocarbon which is also having oxygen or nitrogen or sulfur, something like this, they would have mentioned there. Okay. Chalo. Now next is the question is when 0.01, now they are saying that when 0.01 mole of organic compound containing 60% of carbon was burnt completely, right? It was burnt completely, 4.4 gram of CO2 was produced. The molar mass of the compound is. Okay? Beta, in these questions again I am saying that the biggest, toughest part is to understand that, right? Okay, very good. Toughest part is to understand what is the concept here, what we have to apply here, right? So this much of organic compound containing 60% of carbon, 60% of carbon was that was completely burnt in 4.4 of carbon dioxide. Okay. There was some organic compound. Okay. We don't know which is that organic compound. There was some organic compound which was having 0.01 mole of organic compound, which was having only 60% of carbon. Now, first you have to see the percentage of carbon. Percentage of carbon. First, I'll just tell you the full situation of this question, right? This they have given you. There is some organic compound, right, in which 60% of carbon you will have, right? 60% of carbon of 0.01 mole. Okay, this is what is given to me about the organic compound. Next, they are asking that it was completely burnt. This organic compound was completely burnt. Now, guys, understand one thing about organic compound and its combustion, that if you have some organic compound like this, right, it will burn, it will give you X amount of CO2. That means the number of carbon atoms that you will have in the organic compound will give you the moles of the carbon dioxide. Is that clear to everybody or not? Is that clear to everybody or not? What is the concept here? That basically what I have to see in this, every question will be different only. Okay, everywhere mole concept will be applied. So you have to understand these things. You can't cram these questions. Okay, right? The molar mass of compound is this. They are asking you the molar mass of this compound. Molar mass of compound. This they are asking. It's a very, very good question. Okay, molar mass of this compound. Now, firstly, though, guys, what I have to do is, firstly, I will calculate the right carbon, because what I can see here, this x and this x is going to be same, right? This they have given me 4.4 gram. Can I calculate the number of moles of CO2 here? Beta, can I calculate the number of moles of, very, very good evening, right? Calculate the number of moles of CO2 here. 4.4 divided by 44 gram per mole, it is going to be 0.1 mole. It is going to be 0.1 mole, right? Okay, that is going to be 0.1 mole, right? What about this one? Here they are saying that 60% of the carbon that you have here. Okay, here they are saying that 60% of the carbon of this much. When 0.1 mole of organic compound containing 60% of carbon was burnt completely. How much carbon was burnt? 60% of 0.01. This much is the mass of carbon. This is your mass of carbon, right? Okay, so can I say this will be 60 by 100 multiplied by 0.01? This is the mass of carbon. Everybody, can I say this is the mass of carbon or not? Everybody in the comment section, can I say this is the mass of carbon? Everybody, everyone here, everyone beta. Why I can't see? 0.06, ठीक है. 0.06. 60% of 2. But wait, I have not crammed the answer. Just give me a minute. Right? So this is, if this is the mass of carbon, if I have to calculate the moles of carbon is what? Moles of carbon is mass of carbon, that is 60 by 100 multiplied by 0.1, and this molar mass of carbon is nothing but 12. So can I say these are the moles of carbon that you will have? These are the moles of carbon that you will have, right? Okay. 0.01 mole. Wait a second. Wait a minute, it should be 0.01, na? When this much of organic compound containing 60% of carbon is burnt completely, with this much of CO2 was produced, the molar mass, acha, of the compound now they are asking you, right? Now, what you have to do here, now you just have to equate these two things here, right? Okay, you just have to equate these two things here. How will I equate these two things here? So you can say that the x over here is equals to that thing here, right? So can I say that if I say Cx of Hy, it is going to give us X amount of CO2, right? CO2 I have already calculated as 0.1. That means if this is 0.1, this also should be 0.1, right? Okay, if this is 0.1, this also should be 0.1, right? Okay, so I'll just equate it here. I'll just equate these two things. I'll just tell you over here only, right? So first, this thing too we have already done, right? Okay, this also we have done. Now, in the end, what we are going to do here, right? Till here we have already done. After that, moles of CO2 from combustion is this much. That is, this is the moles of carbon, right? So we are just going to equate these two things here, moles of carbon, and this is your moles of CO2, right? Okay. Wait a minute. Moles of carbon is what? This is 60% of 0.01 mole of carbon. Mass of carbon is 0.60 by this. Wait a minute, guys. When 0.1 mole of organic compound containing 60% of carbon, this is the mole. Organic compound is, wait a minute, something, Wait a minute. When this much of organic compound containing 60% of carbon was burnt completely, this is the mole. So 60% of this, you will get the moles here, right? Okay. So okay. So sorry guys, wait a minute. Let me just clear out one thing here. Let me just clear one thing here. Here 60% of carbon, that means 60 by 100 multiplied by zero point 0.1 will be the moles of carbon, because this is giving the moles. They have given the moles here. Okay, this will be the moles of carbon. So it will be, if you want to calculate the, if you want to equate the mass of this carbon with the moles of this one, because the moles of CO2, because the moles of CO2 is equals to the mass of carbon, right? Okay, so mass of carbon is going to be, moles of carbon is going to be, we know that moles is equals to molar mass by molar mass. So mass is equals to number of moles multiplied by molar mass, right? So here if I am talking about this whole compound here, right, if I am talking about in this proper organic compound, I have this much percentage. So here I'll say that the mass of organic compound, mass of, or you can just directly write, right, that will be equals to 60 by 100 multiplied by zero point 0.1, because moles is equals to mass by molar mass. So mass is equals to number of moles into molar mass. So I'll multiply this with the molar mass. Number of moles I already know, right? Number of moles you already know. You will multiply this by the molar mass, right? So this thing and this thing you will equate, right? These two things you will equate and you will get this thing now. है ना? This thing what they have written here. ठीक है? This thing you will get 60 by 100, right? And you will just multiply this thing over here and you will get your answer over here. ठीक है जी? Okay, right? Huh. Okay, wait a minute. Yeah. Moles we have calculated here. Okay, moles of carbon, it was also calculated there. Okay, chalo. Now next question is, beta, basically here what we have done, right? Okay, I'll just I think I should explain you again that what exactly we have done. We have just counted on this concept here, that x of this much is equals to this much of organic compound, right? So here they have given us this hint here. From that I calculated, right, this was the moles, right, this much percentage they have given us, right? So moles of carbon will be 60 by 100, this is 0.01, right? And this is going to be, because it is 12, so I'll just divide it by 12. So that will become the अपना total moles, है ना? ठीक है? So that will become the total moles. When I divide it by 12, then it will become the total moles. After that, I know that number of moles is equals to mass by weight by molar mass. Now here I am telling you the organic compound, right? Okay. So number of moles of this is equals to same as number of moles of organic compound only. So that's why we will say that this number of moles of carbon is same as number of moles of organic compound, right? Because it will have only one mole. If one mole of carbon you will have one mole of organic compound. So basically this is the number of moles of carbon. This is also the number of moles of organic compound. Moles of organic compound. I'll write it the same way, that is 60 by 100 multiplied by 0.01 divided by 12 here. After that, now again I'll apply this question, that is number of moles is equals to molar mass, weight by molar mass. Now the weight of organic compound will be, right, weight of organic compound will be equals to 60 by 100 into 0.01 divided by 12 into m. Now that weight is nothing but it is equals to this same amount, right? Okay, that's why we have just directly put this value here, and you will get the molar mass as 200 gram per mole. Okay, so it was basically based on that one condition here. Okay, on that one condition, from there also we applied the mole concept. Here also I applied the mole concept 2 times, and then we got the answer. Okay, chalo. Now, next question is the volume of HCl. Next question is the volume of HCl containing 73 gram per liter required completely neutralize NaOH obtained by reacting metallic sodium in water with water. So basically, metallic sodium with water is nothing but it is NaOH. Okay. Now we have one more concept that is same as mole concept, right? There is slight difference. If I say you have N2 plus 3H2, that is going to give 2NH3, right? I'll say 1 mole reacts with 3 mole will give 2 mole of NH3. But if I say equivalents, then I will not say 1, 3, 2. Then I'll say 1 equivalent will react with 3 equivalent. Sorry, 1 equivalent will react with 1 equivalent of H2 to give 1 equivalent of NH3. That means the equivalents are going to be same always. That is called the law of equivalence. So basically, law of equivalence is applied everywhere, right? We don't have to balance that equation. So in law of equivalence, what is number of equivalents? Number of equivalents is equals to moles into n factor. Okay, that you have to apply here. Now, moles into n factor, what does that mean, beta? What does that mean? Now, they are saying the volume of HCl containing 73 something required to completely neutralize NaOH. That means you are having HCl, you are having NaOH, you have to completely neutralize them, right, by reacting this and this. By reacting of metallic sodium with water is the volume of HCl containing this much, okay, required to completely neutralize NaOH by reacting. They're asking you basically volume of HCl. Volume of HCl is what they are asking you, right? For that, what you have to apply the law of equivalence, right? Because I know that number of NaOH should completely neutralize this thing. That means equivalence of NaOH and HCl should be same. That means number of moles of HCl multiplied by n factor of HCl, right, is equals to number of moles of NaOH multiplied by n factor of NaOH. Now, beta, HCl also give us 1 H positive, this also give us 1 OH negative. That means these are equal to each other only, 1, 1, they will cancel out each other. So that means number of moles of HCl is equals to number of moles of NaOH. From here, we will put the values and we will get the answer. The volume of HCl containing 73 gram per liter. Can you tell me what is this gram per liter? Gram is mass and per liter means volume. Okay? So that means something related to volume is given to me. Yes, everybody. That means something related to volume is given to me. Yes, students. HCl, though they have given us mass by volume, they have given us, okay. But with this, what they have given us, required to completely neutralize NaOH obtained by reacting metallic sodium with water, right? Uh, by reacting metallic sodium with water. Wait a minute. Nearest, the volume of HCl is required to completely neutralize NaOH obtained by reacting sodium with this one, okay. Density. I think something is missing in this question. Wait a minute. The volume of HCl containing 73 gram per liter required to completely neutralize NaOH required by reacting metallic sodium with water. Something is missing in this question. Isn't it? Completely neutralize. Okay. है ना, mass of sodium should be given to us. है ना, mass of sodium is missing. Something is missing here. That's why I'm saying the question is not complete. The volume of HCl, right? This should be given to us. Okay. I'll just check it. What is the mass of the sodium? I'll just check it. Right. Okay, guys, just give me a second. Right. Okay, I'll just Google. Beta, mass of sodium. Molar mass, nahi, I am talking about. Mass. You have to know the mass. Right. Okay, so I'll just see the mass. Right. Okay. 0.69. Beta, write it here because it is missing, okay? To neutralize 0.69 gram, okay? This will be given in the question only, right? 0.69 gram of NaOH by reacting sodium, okay? So what is the sodium? Sodium will be points by reacting of metallic, na, here it is missing. 0.69, okay, 0.69 gram of sodium is being reacted. Now we have the full-fledged question, right? So if here number of moles, here you have number of moles of HCl. Number of moles of NaOH is what? Given mass by molar mass. Given mass of sodium is 23, right? Molar mass is 23, given mass is given to be 0.69. Okay? And what about HCl? What about HCl? HCl molar mass is given to you already. What is the molar mass? That is 36.5, right? That is the molar mass. But ma'am, the mass of HCl is not given to us, right? The mass of HCl is not given to us. So let us see, density is equals to mass by volume, right? They are asking the volume, right? So mass is equals to density into volume, right? So basically mass that you will put the density in gram per liter and the volume you will get in liters, right? Volume you will get in liters. So here this will be density, that is 73 multiplied by volume, right? This will be in liters. You will get this volume in liters, right? Okay, you'll just get this value in liters, right? Then you'll have to convert it into milliliters, right? 23 multiplied by 36.5 divided by 73. Okay, solve this value and you will get this in liters, okay, not in milliliters, right? Okay, okay, students, right? Okay, what you will get, everybody, whatever you will get, you will just multiply this by 10 raised to power 3 and you will get the answer in milliliters. What you will get here? But ma'am, NaOH, acha, you want to know about NaOH? Also write it here. Basically, beta, what we have is they are asking that sodium in water, right? Sodium in water, it will give you NaOH, right? So 1 mole of sodium will give you 1 mole of NaOH. That is why if you say this is 0.69 divided by 23 mole of sodium will give you 0.69 by 23 mole of NaOH. So that's why I have taken the mole of sodium and NaOH as same only, right? 1.5 milliliter, the 0.015 milliliter it is coming out to be. So you just put it here. 1.5 into 10 raised to power minus 2. So it will come out to be 15 liters. Right. So answer will be this will be in milliliters. Right now the answer will be in liters. 15 milliliters. That will be the answer. Okay. Chalo. So the question was not complete here, but now it is complete. Acha. Now they are saying that same amount of dichloromethane is added to 67.141 milliliter of chloroform. Again, firstly, so you have to understand that what they are saying here, right? What is the concept? Some amount of dichloromethane is added to this much milliliter of chloroform. That means chloroform is our solvent, right? This is our solute. Okay? So that is added to this much chloroform to prepare this molarity solution of CH2Cl2 DCM, right? Okay? Okay? Then the concentration of DCM, that is the solution. The concentration of solution is dash ppm by mass, that is weight by weight ppm you have to calculate. Other things they have given to us. So that means from one concentration term, you have to calculate the other concentration term here, right? From one concentration term to the other concentration term, right? Okay, everybody, from one concentration term to other concentration term. Acha, firstly tell me, they have given you molarity here. What is molarity? Molarity is equals to number of moles of solute, some amount we don't know. Let's take it as W, right? CH2Cl2, CH2Cl2 guys, that will be 70, 80, that will be 70, 80 to 84, है ना? It will be 84, right? So 70, 71 है ना? So it will be 35.5, 71 plus 12 plus 2, so it will be 85. This is the molar mass, right? Okay. So weight by divided by number of moles of solute divided by volume of solution. If the volume is in milliliters, then what you will do? You will multiply this by 1000. So I'll multiply this by 1000. So from here I can say that I can calculate the weight of CH2Cl2. Can I calculate? Yes, ma'am, you can definitely calculate. They are asking me one thing. They are asking me the ppm by mass, that is weight. What is ppm? Weight by weight ppm. What is weight by weight ppm? That is weight of solute. Weight of solute, that is CH2Cl2, that we will calculate from there, right? The concentration of DCM, they are saying the atomic mass of this is weight of this. Acha, to prepare this much DCM, what they have given us? Weight by weight, na, some amount of this much is added to this much of chloroform, right? Chloroform, milliliter. What other thing they have? Acha, this have given us this density. Acha, they have given us this density, guys, okay? They have given the density here. So density of CH chloroform is given to me. Volume of chloroform is given to me. So density is equals to mass by volume. So mass is equals to density into volume. So can I say that I'll just multiply the density? Density is in 1.49 multiplied by the volume. Volume is in milliliters, right? So it is 6671, right? Okay, 0.141. Okay. So after that, I'll just put this value here and I'll get the answer for weight by weight. Okay. Beta, ma'am, can you explain? Acha. देखो बेटा, you have a solution, ठीक है, in which you have dichloromethane CH2Cl2 and you have chloroform. This is the solute, this is the solvent. They have given you two hints here. One is molarity, other is the ppm. They have given you the molarity, they have given you that this is the solute, so you can easily calculate the mass of solute here, right? Volume is given to you. If volume is in milliliters, you will multiply this by 1000. From there, you will get the weight of CH2Cl2. ppm, they are asking weight of CH2Cl2, you will calculate it from here. Now, we don't know the weight of the solution. We know that solution and solvent are approximately similar only because very little solute is added here, right? So here it is volume and here you have the density. Density is equals to mass by volume. So that means mass is equals to density by volume. Can you say mass is equals to density into volume? So I just put the value of mass and density here. I just put the value of density that is given to me 1.49. It is 671.141, and I'll just put the values and I'll get the answer. Got it? Okay. Okay, guys. So that's it. Okay, just have to solve this after that. Simply take care. So what weight you will get? The weight you will get it as 0.148. You will put the value here. Acha, we also have to multiply this by 10 raised to power 6 because it is ppm we are calculating now. So multiply this by 10 raised to power 6 and you will get your answer. Okay, got it? Next is the density of 3 mole. Now what they are asking, see again you have to see every single question is different. Okay, so density of 3 molar solution. Now they are saying you have 3 molar solution. Molality is given to you. Molarity is given to you. Then molality they are asking you. Acha, here to you can directly apply the formula. How many of you remember that formula? Beta, here to directly apply that formula. The formula is m into 1000 molarity divided by 1000 into density minus molarity molar weight of solute. Right? Everything is given to you. Molarity is given to be 3. Right? Molarity is 3. This density is given to be 1. Right? Density is given to be 1 gram per milliliter. Density is given to be 1. Right? 3 into molar weight of solute. What is solute? Solute is NaCl. Its molar weight is nothing but 58.5. So you'll get the answer here. Okay? Directly formula based question it is. Okay? Acha. Next question is, what is the mass ratio? Now they are saying what is the mass ratio of ethylene glycol? You have molar mass required for making 500 gram of 0.25 molar aqueous solution as 250 milliliter of this much molar solution. So basically again they have given us two things here. Okay, two things they have given us. What is the mass ratio of ethylene glycol? Molar mass is given to you, required for making 500 gram of this much molar aqueous solution and 250 milliliter of this much. Okay. Okay. So molarity and molality, two things are given to you. Mass ratio they want to know, right? Ethylene glycol molar mass is 62. So we know that if you talk about the mass, W by molar mass is 62. This is, if I multiply this by 1000, then the weight in kilograms, weight in grams we are writing, so it will be 500 here, right? So that is going to be the 0.25 is the molality. Okay, so W is going to be, I am adding W1 here, W1 is going to be 500, this is going to be 2, so it is going to be 31. So it is going to be 0.25 multiplied by 31. What about this thing here? They have given you the molarity. It is again 0.25. This is W2, right? So this is divided by 62 only. This is 1000 only, but here it is 250 milliliters, right? So here it is going to be 4, right? Everything else is going to be same. This is 2, this is 32, right? Okay. Sorry, it is 31. No, it will be 31, right? So it will be W2 is going to be 0.25 multiplied by 31 divided by 2. So they are asking you the ratio here. That is W1 by W2, something they are asking you. So just have to write the ratio here. W1 ratio W2, it is going to be 2.5 multiplied by 31. 0.25 multiplied by 31 and it is 2, so it is going to cancel each other. It is going to be 2:1. So answer is going to be C is the correct answer. Okay. Acha. Now they are asking you when an hydrocarbon, they are saying that there is some hydrocarbon, right? A undergoes. Now what it is undergoing, right? Okay. Okay. Huh. Very good, Sachin. Very good, Sachin. So when a hydrocarbon A undergoes, okay. When a hydrocarbon A undergoes combustion in the presence of air, it requires 9.5 equivalents of oxygen and produces 3 equivalents of water. Right? Okay. What is the molecular formula of A? So that means equivalence you have to equate here. When a hydrocarbon A undergoes combustion in the presence of air, it requires, see here you need to understand the direct formula here, that this is the method. This is what I was telling you, 6x H by, it is going to give you X amount of CO2. Now here they have given us that you have 9.5 equivalent of oxygen. That means X plus Y by 2 is 9.5, and they have given us produces 3 equivalents of water. So 3 equivalents means Y by 2 is equals to 3. Right? So that means here you can calculate Y is equals to 6. Put the value of 6 here. You will get the value of X as 8, and that is going to be your answer. Okay, that is going to be your answer. Simple question it was. Next is volume of 3 molar NaOH. Now if you have 3 molar NaOH, you have molarity. Formula weight is going to be this much. Okay, formula weight is molar weight only. Right? You have volume of 3 molar NaOH is given to you, which can be prepared from 84 gram of NaOH is. Okay? Molarity is given to you guys. They are asking you the volume here. Beta, apply the formula here. Okay, apply the formula, everybody. Just apply the formula here. Everyone just apply the formula. Okay? So what you have to just apply the formula. It is 3, right? Molarity is equals to number of moles. Number of moles, what is the weight? Weight is given to be 84, right? It is, formula weight is 40. Okay, so it is going to be number of moles is equals to, this is 1000, and this is going to be the volume in milliliters. So you'll just have to calculate the volume in milliliter, right? 84 by 40 multiplied by 1000 divided by 3, and it is going to be the answer. Okay, right? Okay, beta, this is going to be the answer. Simply just calculate this, you will get your answer. Okay, okay ji, chalo. Now next question is, they are saying that 9.3 gram of aniline is subjected to a reaction with excess of acidic anhydride to prepare acetanilide. So why I have picked up this question? Because na abhi they are giving you question from mixed questions, like maybe sometimes they will add organic chemistry in physical chemistry. So it's a mixed question of organic and physical chemistry. Mostly they can add physical chemistry with organic chemistry. Most of the question you will see like that. Not most of the question means good questions you will see like that. Right, 9.3 gram of aniline is subjected to reaction with excess of acetanilide to prepare acetanilide. The mass of acetylene produced if the reaction is 100% completed is this one. Now guys, if you see this reaction here, this is the reaction, okay? So here you have aniline with you have acid anhydride, right? Okay, subjected to excess of acid anhydride to the preparation of acetanilide, right? So this is what you will get here. That means you will replace this hydrogen with CO, CH3, you have replaced this. This same reaction we have already done in organic chemistry. You are not unaware of this reaction. We have already done this reaction in organic chemistry. Now they have just merged these two things together. We know that if they are comparing, see, now let's see the moles here. This much gram of aniline they are asking, they have given aniline, and they have given us the mass of acetanilide. That means aniline is this thing, and this is the acetanilide. So that means I have to compare these two things. I know that the number of moles of aniline and the number of moles of acetanilide is same. So I'll just equate it, the number of moles of acetanilide and aniline is same. Aniline beta, I already know the molecular formula, right? So I'll know the molecular mass also, that is 93. Acha, given mass is already given to me in the question, that is 9.3. It is given to me. I don't know the mass of acetanilide. I'll take it as M or W, whatever you want to take. Now from this particular thing, you can easily calculate the molar mass. Okay? By adding carbon is 12, nitrogen 14, you can calculate the molar mass. put the molar mass, then you will get the weight here. Okay, so these are basically the mixed question of organic and physical chemistry. Okay, right? Very good, Manish, very good. Right, so these are mixed question and they are not difficult, they are very, very simple questions. Okay, now next is point 3. Now this is also different questions. I have tried my best to pick up different questions. I have not picked up similar questions here. I have picked up different questions. Okay, like this question was a different question because students usually skip these simple questions. These are actually very, very simple. Right, similarly with this one, this is not a very tough question, this is also simple question. You have 0.05 centimeter thick coating of silver deposited on the plate. First you have to imagine this. You have a 0.6 thick coating of silver deposited on a plate of this much area. Area is given, length is given. Number of silver atom deposited on the plate are this much. Ma'am, what is this, ma'am? What they have given us here? Beta dekho. Density is given to you. Okay? Density is given to you. Density is equals to mass by volume. If I say mass is equals to density by volume, right? Mass is equals to density multiplied by volume. So density is given to me. Volume is not given to me, but I can easily calculate the volume because this is area, right? I'll just multiply this thing with this one, right? Okay, I'll convert this into centimeter also. I'll multiply these two things together, right? And after that, I'll get the volume. Then I'll multiply with the density. I'll get the mass of Ag. I know the molar mass. Okay? So I'll get the number of moles is equals to, chalo, firstly do one by one. Okay, let's do one by one. Volume is the thickness, area. Very good, very good, very good. Very good, beta. So everybody, what is the volume? What is the volume? Acha beta, now I have already told you how to calculate. Now I want you guys to do it yourself. What is the volume? Volume is going to be 0.05 multiplied by 0.05. This is like 0.05 cube multiplied by 100 square because this is converted into centimeter, right? So this will be centimeter cube is going to be the answer for this one, right? So let us see what is going to be the answer. Yes, everybody, what is going to be the answer? Yes, everybody, it will be 1, 2, 3, 4, 5, 6, right? Okay. 0.05 into 0.05. Why I have multiplied this 3 times? 2 times only it will happen, no? 2 times. It is length and this is area. Okay? So it will be 2 times. So it will be 1, 2, 3, 4. It will be 10 raised to power 4. 10 raised to power 4. It will be 25. So it will be 25 centimeter cube, right? Okay, 25 centimeter cube. Acha. Now we know that here it is density is equals to 7.9. So mass of Ag is going to be 25 into 7.9 gram. Okay, that is going to be the answer. After that, I'll just calculate the value of number of moles. I'll just put it here. So this is going to be mass is 108, molar mass is 108, right? This is 25 into 10, 25 into 7.9, 25 into 7.9, this is going to be divided by 108, right? Equals to, okay? Equals to mass by molar mass equals to what? Equals to number of particles they are saying. So just multiply this by Avogadro's number. That will be the number of Ag atoms. Ag atoms. Okay. Just put the value 25 multiplied by other than you have just calculation 108. 6.022 into 10 raised to power 23. Right. You just have to solve this particular thing. That will be the answer that you will have. Okay. Okay. Chal. That's it. Okay. That will be your answer. Next question on your screen we have number of moles of methane required to produce 11 gram of CO2 after combustion is. Guys, everyone beta, this is a very A simple question, okay? Very, very simple. The number of moles of methane required to produce 11 gram of CO2, right, after combustion. If you talk about methane, you just have to firstly know the balanced equation here, right? So if you talk about the balanced equation, this is going to be the general equation of alkane. This also we have done in organic chemistry, general reaction for alkane, alkene, alkyne. Already told you in hydrocarbons, right? Okay. Basically, in if you talk about in alkenes, here so they will always ask you about combustion is for alkane only, right? In alkene we know that there is +2 and +1, and +1 will not exist. In alkyne we know that here it will be -2, it will be -1, it will be -1. Okay, so that is how it is. But now this is a general equation. You will put the value when you put methane, it will be this much. Now they are saying that 11 gram of CO2. CO2 is the main focus, beta. This is a question of stoichiometry. CO2 is the main focus, and they are asking the number of moles of methane. That means this one. Just calculate the number of moles of CO2. Number of moles of CO2 is going to be given mass, that is 11, by what is the molar mass? 44. So it is going to be 0.25 mole. That is going to be the number of moles of CO2. We know that number of moles of CO2 and methane are same. So that will be equals to number of moles of methane also. It's a very, very simple question. The answer will be 0.25. Very, very simple question. Okay. Okay guys, chalo, done. Now beta, a very, very important chapter, right? That is structure of atom will be doing, right? Okay. Okay beta, now we will be doing structure of atom. ठीक है? देखो, let me be very clear to you. From mole concept, they can ask you maybe 1 or 2 questions. Okay, maybe 1 or 2 questions. Yes, I'll give you the break. Or those 1 and 2 questions are mostly it is going to be mole concept. The question that I have shown you here, this was also stoichiometry, basically mole concept. This was also nothing but mole concept only. This was also mole concept only, right? So mole concept is applied in different ways, right? And every question will be different here, right? So you have to do it that way. All the question will be based on mole concept, or maybe very rare chances that they can also ask you on empirical formula or limiting reagent. These are the hot topics of mole concept. Mostly it will be general stoichiometry based questions. Okay, that is a high guess. Now from structure of atom, 2 to 3 questions you can expect. Okay, it's a very, very important chapter. It's a very scoring chapter, right? So and it's a very lengthy chapter. Okay, let me tell you, it's a very, very lengthy chapter. As you can see here, like too many notes I have already prepared for you, like this. Okay, I'll just show you. Like this, beta, I have already prepared notes for you, right? So we'll go through the notes firstly, then we'll go through the questions, okay? Right? It will take us maybe 1 hour to go through the notes, then 1 hour to go through the questions. Okay? Done? Okay, beta? Okay. Now I'll give you the break now. Okay? After the break, we'll start with the structure of atom, because yeah, this is a very important chapter and you can't skip this chapter. Mole concept so definitely you can't skip, because without mole concept you won't be able to understand anything, right? That is applied everywhere. But structure of atom is an individual chapter that will give you the marks. Okay, so I am give you it's 2 questions, like for sure you will get 2 questions, and the questions are really, really simple, guys. I'm telling you, mole concept still, mole concept, I can't say that in the exam you will be able to solve it or not. Reason being, because stoichiometry, sometimes it clicks, sometimes it doesn't click, right? So my advice is, don't give, like mole concept, you should know the basics, because basics are applied everywhere, but don't get too much involved in mole concept at this point of time. But high priority chapter is structure of atom, right? Every single formula you should know, and trust me, here the questions will be answered in 2 to 3 seconds, right? Some questions are very, very simple. Okay, okay, chalo. हाँ जी. Now, beta, I'll give you the break. Beta, I'll let you know in the end of the class. You can solve the Tattva books. You can solve JEE previous year questions, right? Other, because I have not picked up all the previous year questions. I have picked up the selected questions, right? Okay, so you can solve the other questions as well, right? Okay. Now, I'll just resume the class at 7:10 p.m. Or what amount of break you want? 7 p.m. only will work. 7 p.m. will work to all of you. At 7 p.m., 10 minutes break I'll be giving you. Okay? 10-minute break is enough, I think. Right? Okay? Chal. Okay, then I'll give you 10 minutes break. After 10 minutes, I'm going to see you at 7 p.m. I'll just put the break here. Array. I think the board is like, I don't want to give the students the break. Now the board is ready. Hello, hello. Guys, let me just inform you one thing, that the break will get over at 7:10 p.m. Okay. So basically, I thought that I don't want to give you another break. So I thought I'll also have dinner, right? So dinner will prepare, you know, out of that I'll eat the dinner also. It will take me around 15 minutes. You also have your dinner, and after that we'll join and we'll finish the class by 9 or 9:30. After that, you can enjoy your new year, right? I'll also enjoy my new year, right? So yes. Hello, hello, hello. Okay, yes, everybody, am I visible and audible? So I am back. So how many hours, yeah? How many hours? Just how many hours to 2025? Huh? How many hours? Everybody, we are we are ending this year, right? And next 2025, 1st of Jan, that is going to start in just few hours, right? So are you all excited for the new year? Everybody, are you all excited for new year or not? Excited? Very good. 5 hours left. 5.49 hours left. Okay, so in next 2 hours, we're going to complete structure of atoms, and after that, you can go and have fun with your family, with your friends. You can relax, keep your mind relaxed, and just enjoy for 1-2 hours. Okay, you deserve that. Right? Okay. Now, now let us start this. Now, bacha, we were at this thing that is structure of atoms. I'll just quickly summarize this. First thing is electron, protons and neutrons, how the discovery happened. So first thing is Crook. So Crook told us that air is an insulator, but at high voltage, low pressure, it is called a conductor. So when you talk about a air, right, when you have high voltage and low pressure, then it can conduct the electrons can flow from there. That is why in the discharge tubes we will take high voltage and low pressure. Okay, high voltage and low pressure will be taken there. Okay, if I talk about the discovery of electrons, right, firstly though we will have the discovery of electron. We'll have a discharge tube where you will have low pressure, high voltage around 10 kilowatt to 20 kilowatt, and there you will see the cathode rays. So about the cathode rays, the properties are very important for you, right? So cathode rays are basically made up of thing that is called electrons, right? So they are invisible. They move in straight line when there is no electric or magnetic field attached there, right? And they are negatively charged, and their E by M ratio is independent of the gas, because electrons are not dependent, protons are dependent on the gas, right? Okay. Next is deviation of cathode rays. So if you talk about the deviation of cathode rays, if there is no electric or magnetic field, they will move in the straight line. But if there is electric and magnetic field, they will deviate from their path. And the deviation of cathode rays is directly proportional to the electric field applied, directly proportional to the amount of magnetic field applied, and it is directly proportional to the charge that you will have there, and inversely proportional to the mass that you will have, right? Charge mass we have already done, but E by M ratio is very important. This is the E by M ratio of the electron that you have, that is 1.75 into 10 raised to 11 coulomb kilogram. Okay, that comes to be the E by M ratio. Now, if I talk about the oil drop experiment, you don't have to get into the experiment. Basically, in that experiment, there were two forces that basically in that experiment, what you had an oil drop, right? Okay, full experiment, you don't need to get into that. In that oil drop is going to catch the electrons from the X-rays. So there may be one electron, there may be two, there may be three, there may be four, there may be five, there may be six, seven. I'll call it as N. So N number of electrons it will catch. So the total charge on the oil drop, that is Q, is equals to number of electrons that it has caught multiplied by the charge on the electron. Charge on that oil drop, you can experimentally define that, right? Number of electrons you can also experimentally define. From there, he calculated, Millikan's calculated the charge on the electron. So you have to remember this particular formula, and that Millikan's calculated the charge on electron by this experiment. And after that, we were able to answer the E by M ratio, right? Okay. Then there is discovery of protons. Discovery of protons basically means again a proton, see, basically these are canal rays or anode rays. In this now, for example, you have an atom of hydrogen. It has one proton, one neutron, right? One neutron, I'm saying, one proton and one electron it has. So when you take out one electron from here, so this is one proton, one electron. When you take out one electron from here, you will have one proton over here. So in case of hydrogen, you after you take one electron, you will get one proton. But in case of helium, you have two protons, two electrons, two neutrons. In this case, right, when you take out two electrons, you will get two protons and two neutrons, right? At that point, if you say that, ma'am, we never knew about neutrons at that point, but you knew about neutrons, you knew about protons. So that means helium does not break into two different protons. Basically, this means that anode rays are not protons. Anode rays are gaseous ions after losing the electrons, right? They are the gaseous ions that you will have, right? Okay, and they are invisible, they are straight line, they follow a straight line, they are positively charged. Their E by M ratio is dependent on the nature of gas, because we know that helium will have two protons definitely in the nucleus, lithium will have three, beryllium will have four, sodium will have 11 protons, right? So in the same way, protons will not be dissociated. That means the gaseous ion is dependent on the element that you are using, the gas that you are using. So it is dependent on the gas, right? Okay. Now, next is discovery of neutrons. So neutrons are discovered by Chadwick by this experiment. You need to know the experiment, that beryllium, right? On the beryllium, alpha particles were bombarded on it, and you got neutron and carbon 12 isotope from there. Right now, this reaction you need to remember. Other thing is, neutron have zero charge, mass already we have done. E by M ratio, beta. E by M ratio of electron is maximum, then you have proton, then you have neutron has minimum E by M ratio, right? Okay. Then from alpha, beta, gamma particles, what they can ask you? Two things they can ask you, speed or penetration power in comparison. So what are alpha particles? Alpha particles are basically when you take out two electrons from helium atom, that is alpha particle. So helium 2 positive is alpha particle, right? What is beta particle? Electron or positron. These are basically your beta particles, right? Electrons from inner nucleus, negative charge, they are negligible mass. Okay, from the inner nucleus, when you take out the electrons, they have very high energy, right? So they are negatively charged, negligible mass. And neutron, like when neutron will dissociate, it will give us proton, neutron and beta particle. Okay, next time gamma particle. Gamma is a high frequency. When we will do E by EM electromagnetic series, when we will see the spectrum of electromagnetic radiation, in that also you will see that high frequency, right? Gamma particle are at the high frequency range of electromagnetic radiation. That means they have very high energy. That is the reason the speed, penetration power or the energy of gamma is maximum, then you have beta, then you have alpha. But the ionizing power means when it is going out, this is another atom, this is me, right? I'm going here, but I'll take out one electron from here. That is the ionizing power, right? That means to take out electron from there, the ionizing power of alpha is maximum, then you have beta, then you have gamma. These two things are very, very important. Penetration power or speed or energy, you can say, and the ionizing power. Okay. Next is the models. If you talk about the models, first is the Thomson model, right? So first is the Thomson model. Thomson model is like plum pudding, watermelon model. Have you seen watermelon? Never, they will never ask this model. Very simple, right? So red part is called the positive, uniformly distributed positive charge, right? And the seeds, black seeds are the electrons. That was about the Thomson model. Now, next thing is the Rutherford model. So Rutherford model have very important things here. That firstly, what you will have a source of alpha particles here, okay, and you will have a ZNS screen all over here, right? A ZNS screen all over here you will have, and at this point you will have a gold sheet. You will have a gold sheet. So what will happen? The alpha particles will strike here. What will happen? Firstly, what are the observations? that most of the alpha particles, I'm drawing it by this blue pen, most of the alpha particles will vent state. Okay, I'll just mention this, okay, with the help of an atom. For example, I'm drawing one atom here, right? This is the nucleus. Okay, so what we want to say here, that most of the alpha particles vent state without any deflection. Without any deflection, they will vent state. Okay, without any deflection, they will vent state here, right? Now, second is some of the alpha particle. They are saying some of the alpha particles, they will be deflected by some small angle. Okay? They will be deflected by some small angle. And very few, that means 20, that means very few out of 20,000, right? Okay. 1 out of 20,000. It will go and strike the nucleus and bounce back. So these were the 3 observations that we observed here, right? Okay, 3 observations. Out of three observations, what was the conclusion that we made? First thing is most of the atom is empty, but because most of the, see, alpha particles are positively charged, right? Helium-2 positive is positively charged. Nucleus is also positively charged because of proton. Now, because if most of the alpha particles are passing state, that means most of the space inside the atom is empty. Second is positively charged nucleus. Definitely nucleus is positively charged. That is why when it is near to the nucleus, it is deflecting, right? Small and dense, and that nucleus is very small and dense. That is why only few alpha particles out of 20,000 will bounce back there, right? Electron revolve, and they are saying the electron with the negligible mass, they will revolve around the nucleus, right? Charge on the nucleus, they told us that Z is the atomic number multiplied by the charge on the proton, that will be the charge on the nucleus. Radius of the atom will be, they gave you a simple calculation that 10 raised to power minus 10 is the radius of the atom. If I say that radius of the atom is 10 raised to power minus 10, then 10 raised to power minus 15 meter is the radius of the nucleus. That means if this big thing is my nucleus, then this dot is nucleus. This big thing is the atom, then this dot is the nucleus. It is so small as compared to atom, right? Okay. Next is beta, we have radius of atom divided by radius of nucleus is 10 raised to power 5. So volume of atom divided by volume of nucleus will be, because volume is 4 by 3 pi r cube, right? So it will be r cube, that is 10 raised to power 15 only, right? Okay. Now what are the drawbacks? Drawbacks is, first is Maxwell theory, that electron will revolve. See, if you are saying that electron is a charged particle, then charged particle, when it is in the circular motion, it will radiate the energy and it will collapse inside the nucleus. But this doesn't happen. Atom is stable. So he was unable to explain the stability of atom, right? Second is line spectra. He was unable to explain the line spectra also, that how you have specific lines for different compounds, right? So line spectra he was totally unable to explain. How the energies are gained and lost. And isodiaphers, this so we have done. Acha. After this beta, we are moving towards Bohr model, right? A very, very important model. But for that, you need to know about electromagnetic radiation as well. Few questions are asked here, right? So first question is electromagnetic radiation. The full thing here, that what is the spectrum, right? So if you talk about gamma, right, it is having the maximum, like it is towards the maximum frequency side. So it will be radio, micro, infrared, visible, UV, X-rays, gamma, and then cosmics, right? On this line, mu is increasing and lambda is decreasing, right? So this is a very, very important spectra that you have to remember. After that, you have visible region. In visible region, you have VIBGYOR. So in VIBGYOR also, you need to remember with the maximum and minimum frequency. V is having the maximum frequency and red is having the minimum frequency. Wavelength is always opposite to the frequency, right? Now, let us see some formulas from where direct questions are asked. Okay, so if you talk about these formulas, first is if you talk about electromagnetic radiation, lambda is the wavelength. Wavelength is basically if I have this thing. So this wave, if I talk about, right, this wave, if I talk about, this is total, this full length of these two waves is called the wavelength. Okay. Now, mu is the frequency. That means how many times that one wave, this is called one wave. How many times that one wave is occurring at that particular time, that is called the frequency, right? Okay. So lambda is that. Now what is this V bar? V bar is the wave number, that is 1 by lambda. And what is T? Time period is inversely proportional to the frequency. So these are some of the formulas, and mu is equals to C lambda, or you C by lambda, or you can say C is equals to mu lambda. You can remember anything there, right? Now, let us see some of the things here. Very important thing about this lambda, frequency and wave number. If you talk about frequency, that is edible in nature. Even wave number is edible in nature, right? But wavelength is not edible in nature, right? Okay, reciprocal, if you say this thing, if you say 1 by this, you say mu is equals to mu1 plus mu2. So that will be 1 by lambda, because C will cancel each other. C will cancel each other, and you'll be left with 1 by lambda is equals to 1 by lambda 1 plus 1 by lambda 2. Third relation is this 1 by lambda is nothing but wave number. So it will be V bar is equals to V1 bar plus V2 bar. So these are the three important relations that you will have. Okay, that means lambda is not equals to lambda 1 plus lambda 2. Okay, this is not how you will solve it. Rather, 1 by lambda is equals to 1 by lambda 1 plus 1 by lambda 2. Okay, right? Ma'am, what is wave number formula? Beta, wave number is 1 by lambda. Okay, wave number is opposite. Is this the reverse of lambda? That's it. Okay, that is the definition of wave number, right? And if you talk about this formula, over here, that is nothing but 1 by lambda is what wave number. 1 by lambda is 1 is wave number of 1. 1 by lambda 2 is wave number of 2, right? Now, beta, I'll just show you. I'll now in a sequence way we have to remember. Now, next 15 minutes are going to be very, very interesting. Okay, so just give me a minute, because I also drink some water. Right, next 15 minutes are going to be very, very important. Okay. Okay, chalo. Beta, I don't know in physics. Here, so we take it as apna wave number is equals to 1 by lambda only. ठीक है? Okay? चल. Now, beta, please focus here. Now, very important thing. Most of the students, they are not able to understand. Right? That's why I'm telling you the full story you have to understand. Okay? See. So, basically, there was this confusion going on among everyone that wave number or wave nature or the particle nature. That was the biggest confusion that everyone was going through, right? So there were some phenomena that you must have studied in physics which were supporting the wave nature. That is interference, diffraction, dispersion, reflection, refraction. And there were some phenomena that were not supporting the wave nature. That is black body radiation, photoelectric effect, heat capacity, and line spectra. So in our syllabus, we'll study black body radiation and photoelectric effect in detail. Heat capacity, so in thermodynamics, we have line spectra, we will study line spectra also. Right, Lyman-Balmer series, this we will study. Right. Now, first question that students ask me is, ma'am, basically, what is this black body radiation? Right. Okay. So, firstly, we will understand the black body radiation. Guys, black body radiation, understand one thing, that black body is something which can absorb everything. Okay, so it will absorb everything. That is a black body, and there is no pure black body. If you say iron, that is the example that is given in your NCERT. That is not a pure black body, that is a gray body. Okay, now it is very close to the black body, right? So now we are saying that as temperature increases, so basically what is the observation? Observation is that red is becoming yellow as the temperature is increasing. Red is becoming yellow, then yellow to white, then white to blue. That means, can I say that the frequency here is increasing. From red to blue, the frequency is increasing. That means as the temperature is increasing, the frequency is increasing. That was the confusion. But according to electromagnetic radiation, if I talk in electromagnetic radiation, I am taking these things as light, as wave. I am not taking it as particle, right? Okay. So that is the reason when we talk about a wave, we say that energy is directly proportional to the intensity, and intensity is square of the amplitude. What is amplitude? If I talk about a wave, this is the amplitude. This is the amplitude. Now the confusion that was there, that here we are saying that energy is dependent on the frequency, right? And here we are saying that energy has no link. If you say this is electromagnetic radiation, then there is no link with the frequency. But as frequency is increasing here, that means there should be some relation with the frequency, right? So that is the reason it is independent of frequency, so it should have the same color. Hai na? So it is independent of the frequency, there the color should be same. But the color is changing with temperature. That means as the temperature we are providing, energy is changing. Hai na? Energy is changing, the color is changing. That means energy is dependent on the frequency. Beta, this was way before that formula E is equals to h mu. At this point, there was no formula of E is equal to h mu, right? At this point, this was this discussion going on. Why I am teaching this? Because on black body radiation, a question has been asked in your last year, right? Okay, so that's why I am teaching you this. Now, now what will happen? Basically, if I teach you, this is the real graph, this is the expected graph. Now, first problem was this one, that how on increasing the temperature, color is changing. Because color is changing, that is why frequency is changing. But we are saying that it is a wave, so it should not be dependent on the frequency. So first question was that how energy is dependent on the frequency. How can you say that, right? That was the first question, right? Second question was, we drew a graph between lambda and intensity. This is the real graph from the experiment and this is the expected graph. Now again there was this, now this though you don't have to get into details, just remember one thing, that how come Planck is so important for us, right? Planck constant is so important for us because Planck gave the solution for this thing. You don't have to learn the equation, nothing, right? Just remember, Planck gave the solution to this thing. Planck said that, okay guys, I have the solution. I have made an equation. That was a complicated equation that you don't need to see, right? Planck said that I made an equation for you guys where on putting the values, you will get the real graph just like this, where it is firstly increasing to maxima, then again it is decreasing. Now, because Planck has solved this big problem of this graph, right? That is the reason. After that, when Planck said that actually this radiation is not only a wave, it is a particle. It also exists in particle and it shows quantization. It shows quantization as E is equals to h mu. If you say energy exists in packets of h mu, that is why we say h is the Planck's constant, mu is the frequency. He gave us the energy dependence on the frequency. Got it? Okay, beta. He gave us the energy dependence. That is why he solved two problems here. He firstly gave us the energy dependence on the frequency, that how light is changing, and how the color is changing, because energy, as you give the temperature, right, energy is increasing. That is why frequency is also increasing. That is the reason it is directly dependent on the frequency. That is why this formula was accepted. He also, this is a simpler formula, he made one more equation, right? By that equation, that is a similar equation to this one, but that is a little complicated equation. That is not in your syllabus. He gave one more equation where he was able to draw the real graph. So he solved these two problems. That is why right now we study Planck's constant. Okay, right? Okay. Now, so E is equals to h mu. It means energy is in form of packets, right? So he said that energy is always in the form of packets. Energy is also a wave and also a this. Now, from this particular page, the question of your JEE means has been asked. So what they have asked you? They have asked you that this is your graph. First, you need to remember one thing, that temperature, this is the important thing that you need to remember. Okay, this is the thing that you need to remember. That lambda max is inversely proportional to the temperature. If I say T2 is greater than T1, in that case, this lambda max here of lambda 2 will be less as compared to lambda 1 max. देखो, T2 is greater than T1, but lambda max of 2 is less than lambda max of 1. That means these two are inversely proportional to each other. This is given by Wien's law, that is lambda max into temperature is equals to this constant. Okay, so this is a very, very interesting thing. Right, 4 hours, 24 minutes to go. Let's hurry up. Okay, now that was the black body radiation, guys. After that, beta, you have photoelectric effect. Okay, before that, let me just show you the Planck's constant also. What is Planck's? Planck's then gave us this equation, E is equals to h mu, that is hc by lambda. Now here some important points I have written here that beta you need to remember. Right, these are very, 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 very important things. Right, okay. So h is 6.6 Planck's constant, 10 raised to power minus 34 joule second. HC, beta, this is very important to solve your numericals. HC is 20 into 10 raised to power 26. HC is 20 into 10 raised to power 26. Right? Okay. This will be joules. Right? Okay. Joules meter. Okay. Joule second, na? This is joule second. This is meter per second. So it will be joule meter. Right? It will be joule meter. Acha. What about 1 electron volt? Now they can also ask you something in electron volt. So 1 electron volt is equals to 1.6 in 10 raised to power minus 19 joules. Very, very important formula, right? That is the same formula. I have written it in different ways, okay, to make the calculations easy. E electron volt, if they ask you energy in electron volt, they have given you lambda in nanometers, you will use 1240. They have given you lambda in angstrom, you will use 12400. Direct formula you can apply here, right? Now let us understand photoelectric effect. Beta, photoelectric effect simply means that you have a metal surface, on the metal surface you have some elements, you have some sodium metal, any metal you take, right? You have one metal, right? So what will happen? A light with intensity will strike here, right? Let's say the light is having intensity h mu. It will take out the electron from that atom, right? It will take out the electron from that atom, and here h mu naught will go, right? And this electron will go with some kinetic energy. So that is why we say that h mu, right? H mu is equals to h mu naught plus k. What is this h mu naught? This is nothing but w naught, that is work function. Right, mu naught is nothing but it is called threshold frequency. Lambda naught is threshold wavelength. Now, what is these three important things? That if h mu is greater, right? If h mu, the power is very greater, so what it will do? If this is very large, then it will take out the electron and also give some kinetic energy. If h mu is less as compared to h mu naught, it does not have any power to take out the electron, then electron will not be ejected. But if h mu is equals to h mu naught, then it will eject the electron, but it will not give the energy. Because if you're like, ma'am, how much, what's the price for this chocolate? It's 20 rupees. 20? Oh, I have only 20 rupees. Okay? So it's like full cancel, right? So it will be able to just take out the electron from here. Now, one question based on this, that if you have kinetic energy is equals to h mu minus mu naught, put the value of mu is equals to c by lambda, put this here, and this is the same formula that you will get by solving this in the form of calculations, right? Okay, chalo. Now, very, very important theoretical based question can be asked to you. First is, if intensity of the photon, that means the number of photons increases, it will have no effect on the kinetic energy. It will affect the number of electrons ejected, right? Intensity, eject, number of electrons ejected means that will tell you the current. So intensity is directly proportional to the current. Frequency, if h mu, if mu increases, then kinetic energy will increase, right? Mu, frequency of photon, it will increase the kinetic energy of the photon, right? Now beta, next is when you want to write kinetic energy, you can also write it in the form of stopping potential. If someone wants to stop it, right, then what we will do, this will be electron into Vs. Vs is the stopping potential, right? Now this is very, very important, right? That is metals. If I talk about the metals, right? If I talk about the metals, size is directly proportional to the work function. Now beta, see, if you talk about this thing here, more the size, more is the work function. Can you tell me the reason? Dekho beta, if you talk about lithium, right? Okay. If you talk about the lithium, right? Lithium. Wait a minute, opposite I have written there. Wait a minute. It should be size is inversely proportional to the work function. It should be size is inversely proportional to the work function. Let me just correct it here. Size is inversely proportional to the work function. I'll tell you how. If I talk about lithium, lithium has small size, right? So outermost electron will be very near to the nucleus. If I talk about sodium, right, outermost electron will be far away. To take out electron from here, it will be easy. To take out electron from here, it will be difficult. So that is why this lithium is going to have more work function as compared to sodium, right? Okay. Okay, beta. Okay, beta. Acha, now let us see the Bohr model, right? Oh, chalo, not too many things we are left with, right? Okay, just 10 more pages and then we will start the questions, right? Okay, chalo, everyone, buck up the speed, everyone, buck up, chalo, shabash. Bohr model, if we talk about, valid only for one electron, that is valid only for one electron. See, Bohr model is uni-electron model, right, for hydrogen, helium 2 positive, lithium 3 positive, lithium 2 positive, helium positive. It is valid for hydrogen, helium positive, lithium 2 positive, right? I'll just write it here, hydrogen, helium positive, lithium 2 positive. It is only valid to uni-electron system, right? Electrons, now they are saying that Rutherford model was a failure. Bohr model said that, okay, that electrons are revolving, but he said that it's not like they are revolving randomly. It's like they have specific houses, right? It's not like they are like lying on the road. They have specific houses and these houses are called orbits, right? So these circular orbits are at specific distance from the nucleus, right? And they have specific energy, they have specific velocity, right? So Bohr model is completely based on numericals and calculations. And from here, a lot of questions are asked. Okay. So first thing, electron lose gain energy in transition, right? So this you don't have to see. Ma'am, do I need to see this? No. Okay. So just remember one thing. Just remember this formula. Why this formula? Because MVR is the angular Bohr momentum, right? Okay, MVR. This is integral multiple of h by 2 pi, or you can say integral multiple of h cut, because h cut is equals to h by 2 pi. Okay, so that is why this becomes very, very important. This is a very, very important postulate of Bohr model, right? Now, beta, they are saying that formula of Bohr model. So these all are the formulas. Just take a snap here, beta. Just take a snap. This is very, very important. Okay, this is very, very important. This is a very, very important chart. Take a snap here. Take a screenshot here, beta. Okay. So Rn radius is equals to 0.52 n square by z angstrom. That is, R is directly proportional to n square by z, right? Vn is equals to 2.1 at 10 to the power 6 z by n meter per second, right? That is V is directly proportional to Z by N. N is the orbit number, Z is the atomic number. Time period, you just remember this thing about time period, that time period is equals directly proportional to N cube, inversely to Z square. But if you remember these formulas, most of the questions, like all the questions of Bohr model, will be solved. Energy, mostly they will ask you question on radius or on energy. Okay, mostly the question are asked on this. Sometimes they can also ask question on velocity or time period, right? Energy is minus 13.6 Z square by N square electron volt, minus 2.18 10 raised to power 18 Z square by N square joule, right? Okay. Now this is a very, very important concept to remember, that if total energy, if I say that potential energy is minus x, then kinetic energy is positive of x by 2 and total energy is negative of x by 2. That means total and kinetic energy are opposite in sign, and potential energy and kinetic energy are same in sign, but they are like kinetic energy, potential energy is 2 into total energy, right? Okay. What about ionization energy? If you talk about energy, here this is negative, negative. Ionization energy means to take out the electron, so sign will be opposite, everything else will remain the same. Okay, chalo. Beta, I think you guys are not interested in reading, in studying, huh? ऐसे ही है, then what should I do? Then I should just directly dump to the questions or what? Then why should I spoil my new year for you guys, huh? हाँ चलो ठीक है, कोई बात नहीं. I'll just give you the notes, you just go through them, right? I don't think so you guys are interested in doing the these like going through the theory part, so it's okay. Very disappointed, but it's okay. Chalo, now let us go through the hydrogen atom beta. Let's see here. This is infinite energy, zero. See, you have to remember one thing, that if you increase the orbit number, right, as you can see, the gap is increasing or decreasing. The gap here is maximum, then it is decreasing, it is decreasing, it is decreasing, it is decreasing. That means as n increases, the energy gap decreases, but energy increases. This is a very, very important relation. Okay, that's a very, very important relation, that as we say n increases, orbit number increases, right, then E increases and delta E decreases, right? Okay, chalo. Now let us talk about Lyman, Balmer, Paschen bracket P fund. If you talk about Lyman series, it is 1, right? That means where the jumping is happening, hai na? If it is from n is equals to 1 to 2, 2 to 3, 3 to 4, like where it is happening. So if you talk about Lyman, always and always, wherever it is coming from, if it is coming down to n is equals to 1, then it is Lyman. If it is coming to n is equals to 2, it is Balmer. 3, it is Paschen. 4, it is bracket. P fund, it is 5. Now, question has been asked on what spectrum they belong to. Lyman belong to UV, Balmer visible, Paschen and bracket and P fund, they belong to infrared region. Okay, chalo. Next is the number of spectral lines. Number of spectral lines, direct formula we will apply. N2 minus N1. This is multiplied by N2 minus N1 plus 1 divided by 2. If you talk about number of spectral lines for specific orbit. Now, ma'am, what is this specific orbit? If I say calculate the number of spectral lines when you have, it is going from N, it is coming from N is equals to 4 to n is equals to 2. So here I have specified, I am not saying the number of lines between n is equals to 4 and 2. I am saying the number of lines that are coming from n is equals to 4 to n is equals to 2. Okay? Their original position is 4 and final position is 2. Right? Okay. So that is the number of spectral lines for specific orbit, that is n high minus n specific. Okay. So if I am specifying that it should come down to n is equals to 2, right? It is coming from n is equals to 6. So it will be 6 minus 2. You will have 4 lines here. If I say that it is coming between 6 and 2, how many spectral lines you have? Then what you will say, it will be 6 minus 2, 6 minus 2 plus 1 divided by 2, that will be 4 into 4 plus 1, 5 by 2, that is 10. 10 will be the answer. Got it? Yes, beta. Chalo. Now, next is, beta, this is very, very important to specify that they can confuse you here, right? Basically, I am using this formula here, that is 1 by lambda is equals to Rydberg constant z square 1 by n1 square minus n2 square, right? RH is the Rydberg constant, that is 109677 centimeters per centimeter. 1 by RH is 912 angstrom. 1 by RH is 912. Beta, this is very, very important because students skip this thing. They just remember RH is 109. If you have to calculate, if you can make the calculations easy by using 1 by RH, you will use 912 angstrom. Right? Very, very important. This is the formula where you're going to put the value of N1 and N2. N1, I already told you, they can give you Lyman, Balmer, Paschen, bracket, P-Fund series. What about N2? So these are the hint written for N2, right? So if you talk about the first line, if they say this is the first line, this is the alpha line, minimum energy, minimum frequency, maximum wavelength, then N2 is equals to, this will be the value of N2. N2 is equals to N1 plus 1. If they are saying last line, limiting line, maximum energy, maximum frequency, minimum wavelength, beta, maximum energy means energy gap is maximum, infinity, infinite orbit. So N2 is going to be infinite. So basically this is the value of N2. N2 is going to be infinite, right? Okay, to N1. Acha. I'll just erase this N1, otherwise so you will get confused. Okay, I'll just erase the N1 here. Definitely it will come to N1 only, right? Acha. Okay. If they talk, see, first line was N1 plus 1, second line is N1 plus 2, third line is N1 plus 3. First line is called alpha, then it is called beta, it is called gamma. So this is a very, very important concept regarding N2, right? So in this, if they want to ask you a very difficult question in JEE means, they will ask you maybe alpha, they will say, maybe beta, you will say. You will not know, only if you don't know what is alpha, beta, how can you solve the, if you know the formula, but you don't know, ma'am, what is alpha, beta line, then you will not be able to solve it, right? So simply this thing they can tell you. N1 is Lyman-Balmer, N2 is this alpha, beta, gamma line, this they can tell you. By this, you will just fill the values in the formula, and you can get the value of lambda also, you can get the value of wave number also, right? Okay, you will get the value of wave number also. Okay, sure. Now, next is, ma'am, what was the failure of Bohr model? Now, Bohr model we have discussed, hydrogen spectra also we have discussed. Now, Bohr model, right? Okay, now we know alpha, beta, gamma. Very good. Acha, what is the failure of Bohr model? Bohr model, beta, from failure also directly the questions are asked, simple questions. That what is Zeeman effect? Zeeman effect is Zum. Zum, just remember Zeeman, Zm, right? So what is this? Zm, right? So Zeeman, just remember this thing. Zeeman, you have M here, na, magnetic field. Zeeman is the splitting of the spectral lines in the presence of magnetic field. Stark is opposite of that. In Stark, you have electric field and the splitting of spectral lines, right? Then you have not valid for multi-electron system. In the first thing only we told you that, okay, this is only applied for one electron system. Arre yaar, flop. Okay, doublets and triplets. Ma'am, what is this doublets, triplets? But basically, when you will study, if you ever study higher chemistry, then this is basically in NMR spectroscopy. Na, these are the wavelengths that you get. And in some waves, what you will get is this kind of thing. So what is this? If I just zoom it in, this is basically something like this. 1, 2. This is doublet. This is called a triplet. When in one wave only you get 3 things, right? So these are the triplets. So doublet and triplets he was also not able to explain. That is not in your syllabus, but just see the drawback. Then you have chemical bond. He was also not able to explain that. why they are so clever to make bond? They are happy in their own orbit. They're like, I am so happy in my own orbit. Then why there is exchange of electron is happening here? What is the need of forming the chemical bonds here? Right? Okay. So now beta will be moving towards quantum theory. Okay. Let's do quantum theory. Okay, ji. Okay, thank you so much. Happy New Year, guys. Happy New Year. Okay, so now let us see de Broglie hypothesis. Okay, so de Broglie, he told you that he was an amazing person, right? Why? He said, okay, basically, this radiation, EM radiation, they have dual nature, right? He said that if you talk about this orbit, you are saying it is revolving in a circular orbit. He said that actually in a particle, if it is in the particle, if electron is existing as a particle, then it is revolving in a circular orbit. If it is existing as a wave, then it is revolving in the circular orbit with this particular wave. This is what he told, right? Okay. So by this, he invented this formula, that is de Broglie hypothesis, de Broglie wavelength. That is lambda is equals to h by p. P is nothing but mv. mv is what? mv is under root 2m ke. This to beta we have seen in lower classes also. Momentum is equals to mv. mv is equals to under root 2m ke. This is physics only, right? So this is under root. If you want to write it in the form of stopping potential, kinetic energy is equals to charge into stopping potential. So charge is Q. If I talk about electron, it will be E, right? Stopping potential is Vs. Now, do you remember I told you that one postulate of Bohr model is very important. Interesting thing about de Broglie hypothesis is that he was also able to explain and get the result of Bohr model here. Bohr model postulate here. He said that we know, if I say this circle is 2 pi r, the circumference of a circle is 2 pi r. 2 pi r is equals to n lambda. And if I say n number of waves it is able to form, and lambda is one wavelength. So can I say 2 pi r is equals to n lambda? Yes. What is lambda? Lambda, we know that it is equals to h by mv. It is equals to h by mv. If you rearrange this will be mvr is equals to nh by 2 pi. That is nothing but this is the postulate of Bohr model. This is the angular momentum of Bohr model. Right? Okay, beta. Got it? This is the angular momentum of Bohr model. After that, then we have one more. Now the duality concept, we were like, okay, this is a electron exists as a dual model. We are clear on that. Heisenberg uncertainty principle. He told that if you are going like this, dancing, then what will happen? See, you will be able to calculate my speed and my position. That, okay, ma'am, you are sitting there. Ma'am, you are there. Ma'am, you are sitting there. Right? If I am moving right now, you are able to calculate my velocity and position, right? It's not a big deal. But with microscopic particles, it's not possible to calculate the velocity and the position at the same time. Simultaneously, you can't calculate. That is Heisenberg uncertainty principle. That is delta x dot delta p is greater than or equals to h by 4 pi. Okay, this is also called as delta x multiplied by m delta v, or you can also take it as energy into time. Okay, so these are the three ways of mentioning this. Okay, ji. Now, beta, will be talking about quantum model. And I think it will take us another maybe 10 minutes to finish quantum model. Chike ji, okay beta. Last thing, waiting for Schrodinger wave equation. Very nice. Do you love Schrodinger wave equation, Ritik, or you hate? If you hate it, then also you must be waiting. I also love this. Acha. Now let us see this, okay? Quantum mechanical model. If you see Schrodinger wave equation, now you'll see this thing, that this is what you will see in all the books, right? So this is a very complicated equation where if I say what is E, E is the energy, E is the energy, V is the potential, V is the potential, right? This psi is the wave function, right? This is the probability, you can say this is the psi square is the probability, okay? You can just write it as probability. This is probability density. This is probability density. Now, first thing you need to know is psi is the wave function. It does not have as such any specific application. But with psi square, basically quantum mechanical model is just, it's like hypothesis. It's not something you can see. Higgs field, if you ever see Higgs field, not see, if you ever like, if you have even gone through any podcast of Higgs field and some, amazing things about quantum mechanics, if you have interest in that, then you must know that, okay, these are all derived theories and hypotheses, right? Okay, by which we are able to explain so many things which we were not able to explain if we don't think about quantum theory, right? Quantum mechanics. So it's a very deep concept, but you have just a layer in your syllabus, right? Otherwise, it's a very important concept and a very deep concept, right? Acha. Here, what you need to remember is energy, potential, wave function, probability function. Acha. First thing is, ma'am, this psi, this is called psi, this psi wave function is the eigenfunction. Eigenfunction, see, function just like subtraction, addition, multiplication, integration, differentiation. This psi is also like a function, right? Okay, it's, see, basically if I, okay, chalo, I'll talk about this thing here. This is called Hamiltonian operator. Hamiltonian operator. Okay? If I talk about this, this is the function. Now, I'll be just giving you one simple example. Function is basically, I have just x square, x cube, e raised to power x, right? These are all the functions, right? If you talk about the operator, operator is subtraction, multiplication, addition, differentiation, integration. So if I say you have, let's take, because Hamiltonian operator is tough operator that you will not study. I'm just giving you one example here. Boson particle hai na? So this is d by dx. I'm just taking one example, random example. I'm taking differentiation. For example, the function is x square. Then the answer will be 2x square. 2x. That will be the answer. But if you take d by dx and you take e raised to power 2x as the function, it will be 2 into e raised to power 2x. है ना? The answer will be 2 into e raised to power 2x. Now, beta, eigenfunction. What is eigenfunction? Eigenfunction is when after applying the operator on the function, you get the same function after that. So, our Hamiltonian operator is same kind of operator which will give you eigenfunction, and the value that you will get here will be the eigenvalue, right? Beta, tell me, is that clear to everyone? So I was just trying to explain you in a simple way that what exactly is eigenfunctions, right? So that is why we call that this psi is a eigenfunction. Okay, that's why we say psi is an eigenfunction. Here we applied operator on x square, but we didn't get x square in return, right? So this is not an eigenvalue eigenfunction. This is an eigenvalue eigenfunction. Okay, acha. So this thing is clear. Now, if you talk about this thing, now I'll just give you a simple chart here to understand what we are moving towards, right? Otherwise, so it's a very simple concept. So basically, what are these? We will be talking about quantum numbers and we'll be talking about graphs in the next 10 minutes. So basically, when you solve any quadratic equation as well, you have some solutions. So this Schrodinger wave equation also had solutions. So it had two kind of solutions. One is real, other is imaginary. Imaginary, we will not talk about, right? Real solutions, we have two kind of things. One is quantum number, other is graphs. Quantum number. Now, beta, one question can be asked. That spin quantum, you have four quantum number, right? Principal, azimuthal and magnetic quantum number are the solution of Schrodinger wave equation. But spin quantum number is not the solution of Schrodinger wave equation. Okay? Right? Okay? Yes, beta, definitely you can watch. Right? Beta, spin quantum number is not the solution of this Schrodinger wave equation. That question can be asked. Very important. Graph, we will talk about that in detail, don't worry, right? Okay, chalo, firstly let us talk about the quantum numbers. Okay, now, okay, so it will be like there is New Year party and you want to go to your friend's home. You ask them, hello, so can you tell me what's your city number, what's your society? I said, okay, my society is principal quantum number. Okay, which house number? House number is acha. House number is azimuthal quantum number. Okay, you entered the house. After that, you said which room number you are in. Room number magnetic, like you are entering the house, right? Room number magnetic quantum number. Then you ask it, Arey, I am in your room. If you see that in the room there is hodgepodge, right? Then you will say negative, minus half. If the room is well decorated, you will say plus half. Very nice. Hai na? So that is how we are going to find the electron here, right? So now electron is our friend. We are going to find the electron, right? So first thing here, first thing is principal quantum number, right? So just imagine the orbits that we were talking about in Bohr model. That is nothing but that is shell only. We call it shell here, right? Here we call it shell. That tells the size and the energy. If you talk about n is equals to 1, it has a very small size and very near to the nucleus. So that is why energy is low. As we increase the n value, the energy will increase, the size will increase, right? Okay. Acha. The value of n can be from 1 up to infinity. Okay. If you talk about value of L, L is azimuthal. So L is nothing but it will be equals to 0 to n minus 1. Just imagine I have n is equals to 2. So for 2 it will be 0 to 2 minus 1 is 1. So it will be 0 and 1. That will be the answer. Right? That will be the answer. Now remember one thing. 0, 1, 2, 3, S, P, D, F. If L is 0, then it is S. If L is 1, then it is P. If L is 2, then it is D. If L is 3, it is equal to F. Right? Okay. Now, after that, what we are going to ask? We are going to ask, Arey, now, it's your friend's house. Your friend said that I live in society number 2. Your friend is living in society number 2. Okay. Then you ask that, Arey, it has 4 houses. It has S. Acha, in n is equals to 2, how many houses you have? So let's take n is equals to 4. Beta, in n is equals to 4, how many houses you have? In n is equals to 4, how many principal azimuthal quantum number? That will be 0 to 3. That is 0, 1, 2, 3. That means S, P, D, F. Now you say, Arey, I can see 4 houses in society number 4. Right? Now, which is your house? He will say, for example, he said that my house is D. Right? For example, he said that my house is D. That means we are going to talk about L is equals to 2. So, for L is equals to 2, M is equals to minus 2 to plus 2. That is why we draw 5 boxes for D. Right? If he said that my house is P, so P is 1. So it will be minus 1 to plus 1. That is why we draw 3 boxes, minus 1, 0 and plus 1. If he said that my house is F, that means 3. So it will be minus 3 to plus 3. So it will have minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. 7 boxes you will draw for F. Understood? Right? Okay. Chalo. Now, this shape. Now, beta, tell me one thing. When you enter a society, right? The house will tell you, when you look at the house, then you will see the shape of the house. Now, some houses are like this, some houses are straight, some houses are only 1 floor, some houses are like a building of 2, 3 floors, right? So, house is going to tell you the shape, right? These houses are going to tell you. Your friend will say, Arey, can you see that house which has red kind of building over it? It has some plants, right? You know how my friends used to define my house. Okay, Diksha's house. It's that house in that colony. If you see a house filled with so many so many pots, right? So much greenery if you see on the terrace, that is Diksha's house. Like, what an identification, right? My house has a terrace like which is like filled with like greenery, everything there. So we have some pots also that are like we have put in some wire, right? So that is why that was the highlight of our house. So that means that shape I am going to tell, right? Acha, what about orientation? After that, what I am going to do, I am going to go into the room, right? So orientation it will tell, right? Your orientation means, if I talk about the orientation, if I talk about P, it you have Px, you have Py, you have Pz. We know that Px is on along the x-axis. This is along y-axis, this is along z-axis. That means orientation is going to tell you the orientation along x, y and z axis, right? Okay, chal. Now, then spin quantum number. This is not a solution of Schrodinger wave equation, but it is going to tell you the rotation, whether it is clockwise or it is anti-clockwise. Got it? Now, beta, very important, direct questions will be asked from here. See, if I talk about orbital, na, this is the orbital, this is subshell, this is shell. Shell, subshell, orbital, then rotate, then your movement. Society number, house number, room number, right? Shell, subshell, orbital, right? Orbital, px, py, pz, what orbital you have. In one orbital, in one box, always you will have 2 electrons, right? That is why number of subshells, if they ask you in terms of principal quantum number of subshells is n, number of orbital is n square, number of electrons in that shell is 2n square. Okay, if they talk in the form of azimuthal quantum number of orbital in the form of azimuthal quantum number is 2l plus 1 and number of electron is 2 into 2l plus 1. Okay, what is angular orbital momentum? Angular orbital momentum is under root L plus 1 h by 2 pi. Angular spin momentum is under root S plus 1 h by 2 pi. Okay, that is the angular spin momentum that you have. Okay. Next, beta, 3 principle that will tell you the electronic configuration, right? First is Aufbau. Aufbau said that, bro, just listen to me one time, that if you want to write down the energy, just listen, that n plus n you just apply. Like, what is n plus l? He said that you have a shell, you have a subshell, just calculate the n plus l value. If n plus l is more, then energy will be more. I said, okay. But I said, but what if n plus l is same? Then he said, no worries. If n plus l is same, then if n value is greater, then energy is greater. Then I told him that, do I have to again calculate this again and again? Then he said, no. Teachers have made some trick. My 12th class teacher told me this trick, I'll tell you the same trick, right? Because I do remember it by that method only, right? So just remember S, P, D, F. Remember 1, 2, 3, 4. Okay, now I'm going to draw that. Beta, one by one we will move. Firstly, we will draw S 2 times. 1, 2. Then we will write P 2 times. P, S, P, S. Then we will write DPS 2 times, DPS 2 times, DPS. Then I also again write DPS. Now again I'll write FDPS 2 times, FDPS, FDPS. Okay, I think in a very, very bad manner I have written this, very hodgepodge manner. So let's write it again. SS, PS, PS, DPS, 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 okay, DPS, FDPS, FDPS, okay. Then I'll just write 1, 1, 2, 2 here. S, we have 1 over it, so we will start from 1, 2, 3, 4, 5, 6, then you have 7, then you have 8. Okay. P starting from 2, so you'll start from 2, 3, 4, 5, then 6, then you have 7. Okay. D is starting from 3. Okay, D is starting from 3. It is D starting from 3. It is 3, 4, 5. Okay, beta 6. F is starting from 4. So we'll start it from there, 4, then 5, that's it. Okay, and you have your energy level, right? So this is a trick to remember this, and you should also know the rules here. Okay, beta. Now, next thing is, ma'am, what you have written here for hydrogen atom? For hydrogen atom, if you have the same value of N, right, then the energy will be same. There is no N plus L rule. If N is same, energy is same. Okay, for only hydrogen, if N is same, energy is same. Right, beta? Now let us do the next rules. Second rule is Hund's rule. In Hund's rule, you have pairing of electron, right? Now, beta, if you talk about Hund's rule said that if you want to pair up the electron, firstly, if you have this kind of p subshell, you want to fill 2 electrons. You will not fill it like this, 1, 2. No, you will fill 1, 2, then you will fill other. That means firstly, all the electrons will be singly filled. If you want to fill 3 electrons, first you will fill third electron here. Not like this, 1, 2, 3. This is the wrong way. How you will do it in the right way? It will be 1, 2, 3. Okay, so that is the Hund's rule, that all the orbitals which are degenerate should be singly filled first. Pauli exclusion principle means you can't have more than 2 electrons in an orbital, and those 2 electrons should have opposite spin. Okay, those 2 electrons should have opposite spin. That means if all the other quantum number are same, at least the spin quantum number will not be same. Right? Okay, chalo. Now, beta, let's talk about the shapes here, right? Acha. Beta, just remember the shapes, okay? If you remember the shape, S is having spherical shape, just write it down here. S is having spherical shape. If you talk about the shape of P, X, P, Y and P, Z, they are along the axis. They are along the axis, and it is having it is having dumbbell shape. Dumbbell shape. That means this kind of shape it is having. Okay? Dumbbell shape it is having along x-axis, y-axis or z-axis. Right? Okay. Chalo ji, beta, already taken. dxy, in d orbital you have dYz, dxy, dyz and dzx. It will have, this will be between the axis, this will be between the axis, and they have double dumbbell shape, double dumbbell shape, double dumbbell shape. Okay. That means it will be something like this. Okay. If I say it is xy, so it will be between x and y. If I say yz, it will be between y and z. If I say zx, it will be between z and x. Acha. Ma'am, what is dx square minus y square? It is along the axis. It will be something like this. This is x and this is y. If I say dz square, it is also along the axis. It is also along the axis. But here there will be a cloud also. Okay? It's not a proper double dumbbell shape. It's a dumbbell shape with a cloud. Right? This is dz square. Okay, so these were the shapes of the orbitals. Okay, now let us talk about nodes and antinodes. Okay, guys. Don't worry, I'll enjoy my new year after this. Don't worry about that. Acha. Okay. Now, if you talk about the next thing, that is nodes, right? So nodes is radial or spherical. Two kinds of nodes we can have. One is radial, other is angular. Radial nodes can be calculated by n minus L minus 1. Angular nodes will be calculated by L. So total nodes will be n minus L minus 1 plus L, that is n minus 1. That is a formula. Very, very important formula. Direct questions are asked here. Right? Okay. Always remember dx square minus y square, dzx, dxy, dyz all have two nodal planes, but dz square has no nodal plane. Okay, this too you have to remember only. If they ask you theoretical question, yes, definitely it's a live class. Okay, acha. If you talk about r, theta and phi, Beta, remember two things. If you talk about a wave function, I told you two kind of solutions we'll talk about. First kind is quantum number, second is the nodes. Right? Node is when the probability of finding the electron is 0 or minimum. Right? So two kind of nodes you have, radial and angular nodes. Mostly we will talk about the radial nodes here. Graph beta, we will talk about the radial nodes. Okay? Three kind of graphs we will draw here. One is versus r, one is psi square versus r, one is 4 pi r square dr psi square versus r. First is radial wave function, second is radial probability density, third is radial probability function curve. Right? These three kind of graphs we will draw with these rules. But if you remember these rules, na, trust me, you don't need to even see the questions. Okay? You will be able to do all the questions. Just go through these rules. Okay? Just remembering these rules is a tough task. Okay? Acha. If we talk about the rules here, if you talk about psi, what is positive negative? Positive negative means the wave it will form will be positive and negative side both. Okay? Psi will form both on positive and negative side, but psi square and 4 pi r square psi square dr, right, that will also form on positive side. That means this graph we will draw on both side, positive and negative. This graph we will draw only on the positive side. This also only on the positive side. That is the first thing. Second is they are saying, if you talk about s orbital, right, then psi and psi square, first two graphs are going to start from maximum. For s orbital, 4 pi, that is the third graph, will start from the minimum. Just remember one thing. For s orbital, psi and psi square will start from maximum. All the other graphs will start from the minimum. For p orbital, d orbital, all the graphs will start from the minimum, right? But for s orbital, psi and psi square will start from the maximum. This is the important point here, okay? Achha. Then you have psi square, peak increases or decreases. In first two graphs, peak will decrease. In the third graph, peak will increase. That means if you talk about these two graphs here, right, here I am saying the peak will decrease, right? That means it will, wait a minute, that means it will go something like this. Okay? Here also the peak will decrease, it will go something, wait a minute, it will go something like this. Here I am saying the peak increases, that means it will go something like this. Got it? Okay? Understood? Chal. Now I am going to draw some graphs in front of you, right? Okay? Maximum these kind of graphs they will ask, okay? So you don't have to worry about anything else, right? Okay? Just give me a second. Acha. Chalo, let's see that. If they ask you for 1s, they are asking for 1s, right? For 1s, beta, first you to calculate the radial nodes. Radial nodes only they will ask you. Radial node is n minus L minus 1. Here, n is equals to 1, L is equals to 0. So, answer will be 0 radial nodes. Now, beta, understand one thing here. This point, if I see this here, na, this point is not regarded as node. The starting and the ending point, if it is touching the x-axis, it is not regarded as node, right? Okay, so here it is 0 node. Psi, it is starting from maximum, right? And it is having 0 node. Psi square is starting from maximum, it is having 0 node. Then you have 4 pi r square dr psi square, it is also having 0 node. Ma'am, it has, ma'am, 2 nodes, ma'am. Arey, I told you, na, ki the minimum point which is touching at x-axis, if it is starting in the ending, that is not the node. You will be more clear over here, right? I'll just draw the nodes with the help of pink, right? So this is a node. The starting and the ending, this ending, this is not the node. This is the node. Here also this is the node. This is not the node. Here also this is the node. This is not the node. This is also not the node. So the starting and the ending point, if it is touching the x-axis, it is not regarded as the node. Okay? ठीक है. So here it is one node, it is one node, it is one node. Here it is starting from maximum, maximum, minimum, right? Here it is having peak is decreasing, peak is decreasing, peak is increasing. Got it? Beta, any problem here? Everybody, any doubt here? Because Dhana, this is important for all of you to understand. Very simple question will be asked here. Hanji beta. Everyone beta, tell me if that is clear so that we can do the life curves. Heartbeat, है ना? अच्छा, last one is beta this magnetic moment, right? Paramagnetic is weakly attracted towards the magnetic field. This is mu is equals to n plus 2 Bohr magneton. N is the unpaired electrons here. If you have paired all the electrons, if you have any unpaired electron, that is paramagnetic. If all the electrons are paired, that is diamagnetic. Okay, chalo, let's do the questions now. Ready for the questions, guys? Now let's speed it up. Let's finish it in next 30 minutes. Okay? Better, definitely this is enough. Right? Definitely this is enough. See for yourself, see the questions and you will get to know. Right? Okay? Yes, students. What's the time? Chalo, by 9 p.m. let's finish this off. Okay? By 9 p.m. let's finish this. I want to see the energy in the comment section. Okay? I want to see your energies in the comment section, guys. Yes, everybody. Let's see your energies in the comment section. Waiting for your response, yeah. Very good, Shabash. More green hearts, more green hearts. Very good. Chalo, let's start with the first question. That is the number of s electrons. They are saying the number of s electrons present in ion with 55 protons in its unipositive state. Right? 55 protons in its unipositive state. So if you talk about unipositive means it will be M positive. So 55 proton means it should have 55 electrons. That means M will have 55 electrons. Right? है ना? M, very good. I can see that energy here. M will have 55 electrons. Right? Now they are saying unipositive means it will lose one electron. Right? So it will become 54 electrons. So in 54 electrons, what is the energy level diagram? Just draw the just write the electronic configuration here. So it will be 1s2, 2s2, 2p6, right? 1s2, 2s2, 2p6, 3s2, 3p6, ठीक है? 4s2, 3d10. How many we have done till here? 30, right? Then you have 5s2, right? 5p6, right? After 5p6, what we had? Wait a minute, let me just see that. After 5p6, beta G, acha, 3p, oops. Just give me a second. हाँ, 4s हो गया. Then we have 3d 4p. अच्छा, 4p we forgot ना. 4p6. Then you have 4s 4p. Then you have 5s 2. ठीक है? After 5s, what you have? Beta, I to just remember this by the trick, okay? So 5p, then you have 5s, 4d 5p 6s. 4d 5p 6s, right? Then what you have? Then you have 6s, 4f 5d. Let us see how many electrons you're able to fill. 2, then you have 10, then you have 6, then you have 2, then you have 14, right? Okay. Then what you have? 5d. I think by now though you must have given your answer. 6p, 7s, 5f. 6p, 7s, 5f. 6p, 7s, 6p, 7s, 5f, oof, 5f, 6d, 7p, 4s, 6d, 7p, 4s, 8s. Beta, let us see how many electrons we have completed till now. 6, 2, 14, right? Then you have 10, then you have 6, then you have 2. Okay? So how many electrons we have completed till now? 8 electrons. Wait a minute, 8 electrons. Wait a minute. Acha. 6, 7, 8, 9, 10, 11, 12, 12, 6, 18, 20, 30, 36, 38, 48, 48, 54. 54 so we have completed here only, is it? 54 we have completed here only, then I was drawing that. Acha. 1, 2, 3, S electrons they are asking na. 4, 5, ठीक है? So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electrons. ठीक है? ऐसे ही unnecessary I drew that. ऐसे I think too much जोश I had. चलो, no worries. ठीक है? We only needed till here. I don't know why I was in so much curiosity to draw everything. Basically, they're asking you S electrons. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Simple question, okay? So answer is 10. Next is the radius. The radius of second orbit. Now, beta, what is the radius of second orbit of lithium 2 positive is X expected radius of third orbit of beryllium 3 positive. Acha. Everybody, everyone try to solve it yourself also. Beta, try to solve it yourself. Yes, everybody here, try to solve it yourself. $54, अच्छा xenon, yeah. हाँ जी बेटा, everybody. Waiting for your answers. Radius of second orbit of lithium. Radius they are asking you second orbit of lithium. Z is 3, Z is 4. Right? Okay. So you have to tell that what is the radius. Done. I think A option. Acha. Ma'am, what is, ma'am, n square by z? Very good. That is R is directly proportional to n square by z. है ना? So after that you just have to solve this thing that they have asked you, that is radius of lithium. Radius of lithium firstly draw, right? Radius of lithium is nothing but it is radius of lithium is equals to radius of lithium they are asking, they said this is x, right? So this is 0.52. N square is what? N square, their second orbit, 2 square. Lithium is 3, so it will be 3 square. So it is going to be 0.524 by 9. Okay, that is x. Now they are saying that, the value of third orbit, the expected radius of third orbit of lithium, third orbit of beryllium is going to be 0.52, ठीक है, multiplied by, this is an angstrom, multiplied by z square, n square, n is what? N is 3, 3 square by 4, 3 square by 4, why I have written square here? It should be 3, it should be 3, it should be 3, right? It should be 4 here. So you just need to eliminate this thing here, right? Okay. If x is, so in the form of x you have to tell that. So you can just take out the value of, you can just take it as a naught. Okay, you can just put the value of a naught, right? You can just put the value of a naught here. Okay, a naught here, you just put the value of a naught here. A naught is equals to 3x by 4. Okay, just put the value here, 3x by 4. That is a naught. This is 3 square. This is 4. Okay. So it will be n square by 4. So it will be 3, 3, 9, 27, 27x by 16. Right? Okay. 27x by 16. So answer is coming out to be C is the correct answer. Okay. Chalo. Next is the shortest wavelength. With a structure of atom, simple questions are asked and very easy questions are asked. The shortest wavelength of hydrogen atom in Lyman series is lambda. The longest wavelength in Balmer series is this. Okay. Okay. Shortest wavelength in Lyman series. Lyman means M1 is equals to 1 and shortest wavelength means lambda, energy will be maximum. That means energy is maximum. That means N2 is equals to infinity. So I'll just draw two lines here. So what we will do, use the formula, right? Okay, that is 1 by lambda is equals to RHZ 1 by N1. N1 is what? 1 square. Okay, 1 square minus 1 by infinity square. So it is going to be 0. So it is going to be RHZ, that is 1, and this is 0. So this is 1 by lambda. So lambda is going to be 1 by RH. They are talking about hydrogen here, so Z is also 1. So lambda is equals to 1 by RH. Okay. They are saying the longest wavelength of Balmer series. Balmer means N1 is equals to 2. Okay. Longest wavelength means minimum energy. Minimum energy will be from when N2 is equals to 3. Okay. When N2 is equals to 3. So I'll just put the value here. 1 by lambda is equals to, they're asking the longest wavelength. I'll take it as lambda dash. Okay. I'll take it as lambda dash. Right? Okay. Because here they have given me the value of RH, right? So RH is equals to 1 by lambda. I'll just put this value over here. Put this value of Rydberg constant on here. RH, what is helium? Hydrogen, helium, lithium. है ना? Here they were talking about hydrogen. Here they are talking about helium. Hydrogen, helium, 2. So it will be 2. 1 by N1 is what? 2 square. This is 1 by 3 square. So it is 1 by, this RH is 1 by lambda only, right? So it is 2. It is 1 by 4 minus 1 by 9, right? So it will be 2 by lambda, 1 by lambda dash. It is equals to, this is 9, 6, 9 minus 4, right? Okay, 9 minus 4. So it will be, let us see. Okay, so it will be 10 by 36 lambda dash. So lambda dash is equals to 36 by lambda by 10. Okay. Why? Balmer series is 2 to 4. The longest wavelength in Balmer series of helium positive ion is 2, right? So it should be why can't I see any option here? Achha. I have not done the full-fledged calculation. 5, this will be 2, 5, 2, 1, 18. 18 by 5. There is no 18 by 5 also. Where we have done the problem? Where there is like, what's the problem? Hai na? What's the confusion? The shortest wavelength of hydrogen atom Lyman series is 1, right? So it is 1. This is 1. So it is 1 by lambda. So I'll just put the value as 1 by lambda. That is 2. Beta, where I have done? Ma'am, Z square. Beta, where? Oh. Then we will, acha, okay. Oops. ठीक है, z square, this will to same only, this will differ here, so it will be 4. Yes, so it will be 4 and this will be 20, and now it will change. This will be lambda dash, wait a minute, lambda dash, this will be 20, this will be lambda dash is equals to 36 lambda, lambda 36 lambda by 20, 2 it is 1 and 8, it is 2 10, so it will be 9 by 5 lambda, है ना, 9 lambda by 5, that is B is the correct answer. हाँ ठीक है ठीक है ठीक है ठीक है, B is the correct answer. Okay, चलो next is we have maximum number of electrons that can be accommodated in shell within n is equals to 4. So maximum number of electrons, this will be 2n square, so it will be 2 4 square, so it will be 32, right? So answer is going to be 32. So simple question this is, right? Okay. Acha, this is an interesting question. Okay, this is a very very interesting question, as you can see here. Dekho beta, the wave function they are saying 2s is given by this thing. Okay, okay. Now at r is equals to r naught, when you put the value of r, radial node is formed. Thus r naught in terms of a naught. Radial node is where you have this function is going to be 0. The probability of finding it going to be 0. So that means this value will be 0, this value will be 0, this whole value will be 0. It means 2 minus r by a naught raised to power something, whatever is given is going to be 0. So it will be, this thing is going to be 0. That means, can I say here that here this thing is going to be 0, right? After that, can I write it just directly as 2 is equals to r by a naught. So r is equals to 2a naught, right? So answer will be r is equals to 2a naught. That is D will be the correct answer. Basically what I did, just put the value here, r is equals to r naught, right? Okay, they said r is equals to r naught at this point, so this will be r naught here, right? At this point when r is equals to r naught, you will have the radial node at that point, right? So basically I put everything as 0 and you will get the value as r naught is equals to 2a naught, right? Okay, chalo beta, bilkul you can do that. Okay, now next is which transition, beta, next is which transition. Let us see how many questions. Which transition in hydrogen spectrum would have same wavelength as Balmer type from n is equals to 2 at n is equals to 3? Okay, everybody, let's solve this question as well. This is, they are saying that which transition hydrogen spectrum would have same wavelength they are saying as the Balmer type for this. See, wavelength is 1 by r, this is Rydberg, right? Z square. They are asking for helium only. So helium, see, which transition the hydrogen spectrum, they have given the value for helium. So it will be 2 square, right? So from 4 to 2, so it will be 2 square minus 4 square. So it is going to be 4RH. This is 1 by lambda. It is going to give you 1 by 4 minus 1 by this is 16, right? Okay, so 4RH, you will just take 4 as common, it will cancel out, you will get 2 minus 1 by 4, you get not 2, you will get 1, okay, 1. So here it will be RH, beta, answer so you can see here, this will be basically 1 square, can I write it as this thing? Now, if I compare this with hydrogen, if I take 1 dash, RH, if I take hydrogen atom, where Z is equals to 1, right? And if I take N1 is equals to, I'll just, in this, can I say Z is equals to 1? From this equation, I have calculated one new equation where Z is equals to 1, this is Z is equals to 2. But here, can I say this is Z is equals to 1? And if N1 is equals to 1 and N2 is equals to 2, then also you will get the same answer. You are getting the same answer here. If you put in the Rydberg equation, if you put the same value as Z is equals to 1, N1 is equals to 1, N2 is equals to 2, you will get the same value. So N1 is 1 and N2 is 2. So answer is going to be C is the correct answer. Wait a minute. To this, N2, N1 is 1. Acha, N1, this to this, na? So this is going to be the correct answer. This to this, okay? So N2 to N1. So this will be 2 to 1, not 1 to 2. Okay? So answer is going to be A is the correct answer. Acha. Next question, as you can see here, arrange the following energy orbitals in decreasing order of the energy. Firstly, to just draw the energies, like what are the subshell, what are the shells they have given you? 3, 4, 3, 3. This is S, S, this is P, this is D. Okay. So we know that if you talk about the energy shell, here N plus L is, see, N plus L is 3, N plus L is 3, N plus L is 4, it is 4, it is 5. So maximum energy is of 3D, that is D. D is having the maximum energy, right? Then there is 4 and 4. The more the value of N, more the value of energy. So that means B is going to have then the next energy, then you will have C, then you will have A. So answer will be B is the correct answer. Okay, chalo, good. Next we have, now this is what I was telling you about the black body radiation, that a very interesting question has been given here on the basis of black body radiation. So following figure shows spectrum of an ideal black body at 4 different temperatures. The number of correct statement from the following is, I told you that this is the statement. So as lambda is decreasing, temperature is increasing. That means T1 is the maximum. T1 is basically, wait a minute. If you talk about this side, right? T4 is the maximum, na? Wait a minute. If I see this here, you need to see that here. If I talk about, if I compare T4 and T3, right? If I say T3 is more as compared to, here they are saying that T4 is more. If I say T4 is more as compared to T3, that lambda of T3 should be less, should be more. Lambda of T3 should be more. Okay? As compared to lambda of, wait a minute, as compared to lambda of 4. Because lambda max and T are inversely proportional. If T is more as compared to, T4 is more as compared to T3, then lambda max of T4 should be less. T4 is more, lambda max of T4 is more, then definitely this is not the correct statement. That means the temperature is like this. It should be T4 minimum, then T3, then T2, then you have T1. Right? Okay, that should be the answer. Right? So this is not the correct statement. The black body consists of particle performing simple harmonic motion, beta. Nothing like this we have studied. Right? Okay. This is also incorrect. The peak of spectrum shift to shorter wavelength as temperature increases. Yes. As temperature is getting increased, the peak is shifting towards shorter wavelength. Right? This, I think I'm doing Hrithik Roshan step. Right? The peak is shifting towards the shorter wavelength, like this and this and this and this shorter wavelength. Right? So this is true. This is true. T1 by mu1 is constant. Definitely beta, that is constant, because we know that lambda and T is constant. So T by mu will also be constant. So answer, yes. Acha, they are saying that T1 by mu1 is equals to T1 by mu2, T3 by mu2. Okay. That will not be constant, right? Okay, the following figure shows spectrum ideal at different temperatures. The number of correct statement from the following is, right? The given spectrum could be explained in quantization of energy. That is true. This is also true, right? They are asking the number of correct statement, na? T1 by mu1, that will be constant only. So this is also wrong. Okay? This is also wrong, because T3 and lambda and T are constant. So that is why T and mu should also be constant. So only two statements are correct here. Okay, this statement and this statement. Okay, only this statement is correct and this statement is correct. Rest of the statements are not correct. Okay, chalo. Next is the number of given orbital which have electron density along the axis. Beta, this is very simple. You tell me this question. Beta, fatavat se tell me the, give me the answer here. Give me the answer. Give me the answer, everybody. Ma'am, when you will see Pushpa 2? Yeah, when I'll get the break, na, I'll go and watch, see Pushpa 2 movie. Also eagerly waiting to see that. Okay, number of given orbitals which have electron density along the axis, right? So this has along the axis 1, 2, 3. This is not along the axis. This is along the axis, along the axis. Basically, 5 of them has along the axis. They don't have along the axis. So answer is 5 is the correct answer. Then you have electrons in a cathode ray tube. They are saying electrons in a cathode ray tube have been emitted with a velocity of 1000 meter per second. The number of following statements which are true about emitted radiation. Firstly, they are saying that de Broglie wavelength. So de Broglie wavelength is equals to m by m is equals to, I'm saying m, h by mv. Mass is constant, velocity is 3 into 10 raised to power 6, right? So the value is, firstly, I'll just tell you this is the value that you will get. Okay, you don't even need to solve this, right? Okay, for an electron of cathode ray, the value that you will get is 6.67 nanometers only. This is the correct value. If you want to solve it, you can also solve it. Okay, Acha, I have not solved it here. You can also solve it here. Okay, just calculate, put the value of this Planck's constant here, put the value of mass as 9 into 10 raised to power minus 31, put the value of velocity 3 into 10 raised to power 18, right, and you will get the answer. So this is a true statement, okay. Electrons have been emitted with a velocity, the number of statements which are true. The characteristics of electrons emitted depend upon the material. Electrons so never depend on the material. Okay? The cathode rays start from cathode to anode, definitely it is right. Okay, nature of emitted electron depends on the nature of gas. No, it is not. For cathode ray, it is not dependent. So B, A and C are true. Okay, two statements are true. That is A and C are the correct statements. Okay, done. Chal. Beta, what about the last question? Beta, this to I told you the shapes. This is along the axis, along the axis, along the axis, along the axis, along the axis. I have already told you the shapes in the theory part. Okay? Chalo. Huh. A and C. Huh. A and C are true. Okay? Next question is, according to the wave particle, everybody, according to the wave particle duality of matter by de Broglie, which of the following graph plot presents most appropriate relationship between wavelength of the electron and momentum? Appropriate relationship. See, lambda is equals to h by mv. They are saying momentum, na? That means inversely proportional. So inversely proportional, which is the graph that you will see for inversely proportional? Inversely proportional, beta. Very good. A is the correct answer. That is the graph for inversely proportional. X is inversely proportional to Y. This is the graph that you will see. Right? Okay. Next question is the number of radial nodes present in 3p. See, in 3p, radial node is n minus L minus 1. So answer will be 3 minus SP 1 minus 1. So it will be 1. So radial node will be, okay, radial node will be 1. Okay, so answer will be A is the correct answer, right? Radial node is going to be 1. Okay, next question is, which of the following electronic configuration would be associated with highest magnetic moment? Beta, highest magnetic moment, it will have, we talk about these things, everyone. Highest magnetic moment, highest magnetic moment, highest magnetic moment, everyone. Yes. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. 1, 2, 3, 4, 5, 6. So it is basically highest magnetic moment means maximum number of unpaired electrons that are present in D6. Okay, it has 4 unpaired electrons. So answer will be D is the correct answer. Right? Okay, chalo shabash. Next is number of electrons present in all the completely filled subshells having n is equals to 4 and s is equals to plus half. Beta, Number of electrons present in all the completely filled subshells. This is n is equals to 4. ठीक है, they are telling you a specific value. Number of electrons present in all the completely filled subshells, which is having only this spin is this one. So it will be 2n square divided by 2, because you are taking out the minus half spin wala electron. So it will be n square, so it will be 4 square, so it is going to be 16. Okay, very good, 16, 16. Next. The correct set of four quantum number for the valence electrons of rubidium atom. The correct set of four quantum numbers for the valence electron of rubidium atom. Everybody. 37 is the atomic number, right? Valence electron you have to tell, right? Okay. So this is basically 5s. Okay. This is also 5s. Okay. This is 5p. This is also 5p. Okay. Everyone here, what will be the answer? Right? देखो बेटा, first thing is बेटा, this is the possible, it's not possible only. If L is 0, then M cannot be 1. ठीक है? And the last electron is filled in 5s. So for 5s, we only had two possibilities where this is not possible. This condition is not possible. So answer will be A is the correct answer. Okay? Answer will be A is the correct answer. Okay? Acha. Next is you have list the following. You have to list the following. Lyman, Balmer, Paston, beta, based on, I told you, simple questions are asked here. Based on this simple where it belongs, right? Very simple. Chalo beta, everybody here. Let me see how many of you are able to answer this. How many of you are able to answer this? Yes, ma'am. Very good. But beta, tell me na. Huh. Very good. Shabash. Very good. So Lyman belongs to UV region, right? Okay. Balmer belongs to visible region. Rest of them belongs to visible region, right? So you just have to see A is 2, B is 4. A is 2, B is 4. A is 2, B is 4 only for this particular thing. So C is the correct answer, right? Okay, chalo. Next statement is, given below are two statements and you have to tell which of the following statement is true here. Which statement is true? The orbitals having same energy are called a degenerate orbital. That is true, right? In the hydrogen atom, 3p and 3d are not degenerate. That is wrong. In hydrogen atom, if the n value is same, then you will have energy will also be same. They will be degenerate. Okay, so answer will be very good. Answer will be statement 1 is true, B is false. So answer is A is the correct. है ना? Easy peasy. Okay. Next is number of spectral lines obtained in helium. The number of spectral lines obtained in helium positive spectra when an electron makes transition from fifth excited state to first. So number of spectral lines, beta, direct formula, N2 minus N1, N2 minus N1 plus 1 divided by 2. N2 is what? 5, fifth excited state. See, whenever they talk about the excited state, you will add 1 to it. So it is 5 plus 1, that is 6. It is first excited state. So 1 plus 1, that is 2. Okay? Excited state means one level above what they have mentioned here. So it will be 6 minus 2. 6 minus 2 plus 1 divided by 2. It will be 4. 5 by 2, 2. It is going to be 10 spectral lines that you will have. So answer is going to be 10 is the correct answer. Is it? 10 is going to be the correct answer. Very good. Okay, next question on your screen. The four quantum numbers for the electron, the outermost orbital of the potassium is. See, potassium beta, they are asking you the outermost orbital. Firstly, they have to cancel out which are not possible. So this is not possible. Just cancel this out. This they are talking about 4D, right? Here they are talking about 4s. Here they are talking about D. So beta potassium, how come D is possible? Okay, this is 2s. In potassium, 4s is also not possible. Okay. The 4 quantum numbers for the electron, the outermost orbital of potassium. Potassium. 4s is 1s2, 2s2, 2s2. So answer will be B. Okay. So this is so very, very near. Very, very near. So this is also answer will be 4s. Okay. Chalo. Then beta answer is, let's see the next one. de Broglie wavelength of an electron in 4th orbit is. देखो बेटा, in 4th orbit they are asking you the de Broglie wavelength. Okay. So de Broglie wavelength is h by mv. ठीक है? h by mv. You can also write the de Broglie wavelength in the form of 2 pi r, the de Broglie hypothesis that I told you. So basically we know that 2 pi r is equals to n pi. The same thing beta what we did there. From that, if you put the value of r as, if you put the value de Broglie wavelength of an electron in 4th orbit, so you have to put the radius. It's a very, very important question. So a naught n square by z. So they are talking about wavelength of the electron in 4th orbit. So that means you will put n is 4 and z basically de Broglie wavelength of an electron in 4th orbit of this is 1. So basically just we have assumed that here z is 1, right? Okay. So here hydrogen they are talking about. So 4 square 2 pi a naught, that is a constant. 4 square, it is now here also orbit number is 4. So it is lambda, right? Beta remember na 2 pi r circumference is equals to n lambda. This I told you. Same thing, just put the value of r here. That's it. What else you have done? Now you can calculate the value of de Broglie wavelength, that is 8 pi a naught. Right? Okay. Chalo. Next is choose the correct statement about Dalton's atomic theory. Now guys, choose the correct statement about Dalton's atomic theory. Everybody choose the correct statement about Dalton's. Ma'am, explain this, ma'am. Beta nothing, it is 2 pi r, okay, is equals to 2 pi r is the circle circumference is equals to n number of lambda. This is the circle and this is the waves. Okay? So it is de Broglie wavelength. So they have mentioned it by d, right? R is what? R is what? A naught n square by z. Z is hydrogen. Okay? Because in the answer there is no z. Okay? In the options also you will not see. So that's why Z is hydrogen only they are talking about, right? This is n square. N is what? 4 square. It is also 4. So this will cancel out. So it will be 8 pi a naught is equals to lambda. Okay. Chalo. Now next is choose the incorrect statement about Dalton's atomic theory. Okay. Chemical reaction involve reorganization, that is true. Okay. Matter consists of indivisible particles. Indivisible. That is true. Atoms, na? Compounds are formed when atoms of different elements combine in any ratio. Not possible, yaar. Water combines in 2:1. Only then water is formed. Compound are formed when atoms of different elements combine in any ratio. When atoms, all the atoms, this so I think statement is by mistake, they have repeated the statement here. All the atoms of the given element have identical properties including identical mass. All the atoms of given element have identical properties. Yes, they have identical mass, identical properties. This is also true. So incorrect statement is this C1. So answer will be C is the correct C is the incorrect option which would they are asking for. Right? Okay. Okay, beta. Chalo. C or D? Beta C. I think by mistake it is written again. By mistake. Okay? Chalo. Achha, next is the maximum number of orbitals which can be identified with n is equals to 4. N is 4 and m is this. So it will be maximum number of orbitals. It will be two orbitals, right? Oh, sorry, one orbital, right? One orbital you will have, maximum orbital which can be identified with n is equals to 4 and m is equals to 0 na. Acha, maximum number of orbitals that can be identified. So n is equals to 4, what you can have? You can have 4s, you can have 4p, you can have 4d, you can have 4f. ठीक है? ठीक है? Okay. Understood? It can also have 1 m is equals to 0. It will also have 1 m is equals to 0. Okay? It will also have 1 m is equals to 0. It will also have 1 m is equals to 0. 1, 2, 3, 4, 5, 6, 7. Okay? It will also have 1 m is equals to 0. So basically 4 orbitals will have m is equals to 0. So answer will be 4 is the correct answer. Okay? Answer will be 4 is the correct answer. Okay? Acha. Next question, guys. On your screen, the incorrect postulate about Dalton atomic theory are incorrect. Now they are asking you. Beta, incorrect postulate they are asking. Huh. 4, 4, 4, beta, 4. Incorrect postulate, bacha, incorrect postulate. Yes, everybody. Acha. Atoms of different elements differ in mass. ठीक है, that is right. Mass consists of divisible, that is wrong. So B is already wrong. Compounds are formed when atoms of different elements combine in fixed ratio, that is also right. All the atoms of given element have different properties including mass. देखो बेटा, very simple question they have asked from Dalton, right? But they have asked it in the statement form. I will not say that they will ask the same question in 2025, but yes, they can ask you some question based on similar theories, maybe on Rutherford, maybe on because in Rutherford they can't ask you a very complicated question, numerical based question. They can ask you a statement based question like this, or maybe on the basis of laws of chemical combination, maybe on the basis of isotopes, isobars. That's why I have also shown you the different definitions, because these kind of questions are asked. Right? Okay. So that's why I told you that theory is also important, because it's not like same question will be repeated. Right? So compounds, that is also true. All the atoms of given elements have different properties including mass. That is not right. Okay. They have, why would they have different properties? Chemical reaction involve reorganization. So B and D is the incorrect. So answer will be B is the correct answer. Okay, beta ji. Okay, next is this one. Now they are saying a hypothetical electromagnetic wave is shown below. The frequency or the wave is x into 10 raised to power 9 hertz. Okay. Frequency of the wave. Okay. So first is the beta lambda. If you say lambda is 1.5 into 4, right? Into 4. Okay. That is 6 picometer. Why? Because lambda means a full wavelength. Okay, for a full wavelength. So it is, if this is 1.4, 1, 2, 3, 4. 4 times of this will be your wavelength. Right? Okay. Now what is frequency? Mu is equals to C by lambda. C is equals to 3 into 10 raised to power 8. And this is 6 into 10 raised to power 6 into 10 raised to power 12. So here you will get your answer. Okay. ठीक है जी. So this will be 1 by 2, right? 0.5. So I think it will become 5 into 10 raised to power 19. है ना? So it will become something 5 into 10 raised to power 19. Right? Okay. है ना? This is, if you convert this in meters, it will be 6 into 10 raised to power minus 12 meters. So we'll put it here. It will be 0.5 into 10 raised to power this is 20, right? So it will become 5 into 10 raised to power 19. So answer will be 5 into 10 raised to power 19. Okay, so answer will be 5. Okay, chalo ji. Next is this is done. Next. Okay, next is compare the following. So beta, compare the following, everybody. Compare the following. Shabash, everyone. Compare the following. Waiting for your answers, guys. Okay, so n plus L. Here it is, n plus L is 5. I'll just write it here. N plus L is 5. N plus L is 4. It is 4. It is 4, 5, 6. It is 3, 4, 5. So 6 is the maximum. That means B is the maximum. B is the maximum. So this is not the answer. This is not the answer. Right? Then A, they are saying themselves only. D, they are saying we just have to see between E and C. Okay, let's see between E and C. E and C, E and C, E and C, E and C. So more the value of N, more is the energy. So E will be more. So that means D is the correct answer. Okay, D is the correct answer. हाँ बेटा, maybe I think in next 10 minutes, because bus we are left with 2-3 more questions. Okay, so in next maybe 5 minutes we'll just end the class. The electronic configuration of isotopes, basically this is from periodic table only, but still, okay, this is from periodic table, but still these kind of questions are asked to you. This is your previous year question, that's why I picked it here. Electronic configuration of isotopes is, atomic number is 99. ठीक है फर्जी, तो it will be after Rn only. ठीक है, okay. Beta, electron, you just calculate the electron if that is equals to 99. Where the electron is equals to 99? Beta, where the electron is equals to 99? Yes, beta. 86 plus 11 plus 2, 6, 7, 8, 9, 99. Yes. So answer is this one. 86 plus 11 plus 2. So 99. So this is going to be the answer. वैसे भी you should know the electronic configuration, but if you don't know, then you can always calculate it this way. Right? Okay? Chal. Okay. Let's do the next question. And here on your screen we have match the following. Right? Okay, guys. So everybody match the following. Everyone. So here it is. Firstly, so they are giving for nitrogen. For nitrogen, nitrogen is helium only. Helium 2s2, 2p, मतलब 1s2, 2s2, 2p, 3. So N is 3. A is 3. ठीक है? A is 3 here. अरे, such a simple question. ठीक है? B is sulfur. Sulfur is what? 16. So B is neon 3s2, 3p4. ठीक है? C is bromine. ठीक है? It's a bromine is argon 3d10 4s2. Basically, it has 4s2. It should not be here. This should not be written here. Wait a minute. It is just 4p5 electrons over here. Right? Halogen, it is belonging to krypton, full noble gas electronic configuration. Okay, so answer is A is the correct answer. Now let's do the next question. Right? Oh, okay. Okay, so guys, we have completed the lecture finally. Right? Okay, so congratulations everyone. Is there any time? Okay. Beta, tomorrow you don't have any chemistry class, and I don't think so you have any physics. I think you have maths class. Okay, wait a minute. I think you have maths class, so you can just go and check that out. And tomorrow is going to be the last day for the offer, right? So let's just go through the offer, that what exactly you have, because today and tomorrow is the last day for that offer. So basically here you have at 999 you are getting a prime course, that is for JEE, prime crash course you are getting here, in class doubt solving practice test every Sunday at 999 you will be getting. And if you want to purchase pro crash course, in that you will also get practice test every Sunday, printed study material delivered at home, right? JEE crash, JEE books will be given to you, 24/7 instant one-on-one doubt solving, that is for 4999. Now, if you want to get enrolled, if you want personalized academic mentor also for personalized guidance, then in class doubt solving practice test printed JEE crash course, then you will get it for 12,000, that 12,999. Okay, you will get it for 12,999. Okay, chalo. So guys, that's it for today, and New year is going to begin in just some time, right? In just coming 2.5 hours, we'll be landing to 2025, and I wish you all the best in the next year. I wish that you get everything that you desire, that you are working hard for, and next year is going to bring a lot of happiness, a lot of smile on everyone's face. And let's just celebrate new year. Right after this, I think you are done for today. Right, you have done mole concept, you have done structure of atom. Acha, don't miss, like, don't, it's not ki tomorrow I will not study, ma'am, tomorrow is new year, ma'am. No, now you can relax. Now you can just go and celebrate new year, spend time with your family, call your best friends, talk to them, right? Have fun chit chats, okay? Just have an amazing time. But, right, tomorrow, right? I'm not saying tomorrow study for 12 hours, but beta, be aware that you have your exam, right? Okay, so don't waste your time tomorrow as well. Today you can enjoy, but tomorrow, please, please, please focus on your studies and also attend the classes, do self study, solve the questions of structure of atom and the mole concept. And I will see you all on 3rd of January, right, where we are going to do the next day 2, where we are going to take up equilibrium, I guess. Just let me check, right, what we are going to take up in the next class. Happy New Year, New Year, New Year. Is it? Wait a minute. Where I have written it? So many things, na, yeah? So many things. Better just give me a second. Let me just see where I have written it. Okay. So, we are going to take up chemical and ionic equilibrium and thermodynamics in the next class. Okay. So, chemical and ionic equilibrium and thermodynamics in the next class, which is going to start at 4:30 p.m. I'll start. Okay. Okay. 4 or 4:30 p.m. I'll schedule the class. Okay. Chalo. Okay then, bye-bye, take care, see you all in the next class, bye-bye and happy new year, have a smile on your face and celebrate your new year, bye-bye.